Good morning, honorable guests, distinguished speakers, presenters, and participants. We have come to the last day of the 2020 International Conference on Radar, Antenna, Microwave, Electronics, and Telecommunications, or Icramet 2020, which is also a part of Indonesia Science Expo 2010 with the theme of fostering innovation through information and communication technologies for smart, sustainable society. Today, we will have one keynote speaker, Assistant Professor José Luis Silva from Instituto Universitario de Lisboa, Portugal. However, unlike the past 2 days of Icramet 2020, we will begin the third day of the conference directly with parallel sessions of sessions 13 and 14. Next is a short morning break, followed by sessions 15 and 16. After that, we will have a rather longer break until 1:10 p.m. for lunch break, and we are going to have our last paper presentations of session 17. The last keynote talk will be delivered at 3 p.m. prior to the closing of the Icramet 2020. Our moderators will start to lead the parallel session shortly, so please enjoy the last day of Icramet 2020. Thank you.
Good morning, everyone. Welcome to Icramet 2020. I'm Arnida Latifah. I'm from Scientific Computing Research Group, Research Center for Informatics. In this morning session, I will be your session chair. So in this session, we have 4 presenters. And if I look at the participant list here, there is still, we still miss one of the presenter, the third presenter. Oh, now I see her. Okay, so I think we can start. We have 4 presenters here. The first one is Mr. Jalu Prakoso from the Research Center for Physics. The second one will be Suryadi from Research Center for Physics. And the third presenter will be Rika Sustika from the Research Center for Informatics. And the last one is Bernardo Sirenden from the Research Center for Physics. So in this session, we have all internal presenter from LIPI, from the Research Center for Physics and Research Center for Informatics. Before we start, I would like to give you some reminders. So for all presenters in this session, please keep your video on until the session finishes. We will have screen capturing session by the end of the presentation. Also, please fill out the attendance from during this session. Our co-host will send you the link in the chat room for the absence. And please have your presentation file ready in order to answer some questions from your slide. The time for each presenter is about 20 minutes long. Please make sure you are present during your question and answer session. In this 20 minutes, it will be breakdown into 15-minute presentation and 5 minutes for discussion. And for the participant who would like to ask a question, please use the raise hand function at participant menu on your Zoom participant list. Okay, I would like to start now. So for the first speaker, I would like to invite Mr. Jalu Prakoso to present her research.
Yes.
Yeah, you ready? Okay, please. I'll give the frame for you.
Hello. Assalamualaikum warahmatullahi wabarakatuh. Hello, everybody. I will present my research result for publication in Icramet 2020. Let's share my presentation. Okay, here. This is my presentation for International Conference on Radar, Antenna, Microwave, Electronic and Telecommunication, or Icramet 2020. My title is Experimental Based Identification Model of Low Fluid Flow Rate Control System. It is me, the presentation. My name Jalu Ahmad Parosa. Also, they are the team member. They are Edi Kurniawan, Hendra Adinanta, Suryadi, and Purwo Wibowo. We are from Research Center for Physics, our institution, Indonesian Institute of Science, or LIPI. My background of research, the low fluid flow rate usually used in the beverage industry, rain gauge, and fuel system. Low fluid flow rate is have a small flow rate and also usually in the small diameter of pipe. We can explain more next. We want to develop excellent control system so it can generate accurate flow measurement for good quality of product. We go in beverage industry for drinking product or good quality of rain gauge measurement. Also in the fuel, we can how to maintain the fuel machine so the it must be use the accurate control for the flow rate in the machine in the transportation particularly. Moreover, adaptive system to robust theory and control, it can be applied in control system for improvement for its model. We can also use the flow meter as feedback element. Also, we can use starter such as solenoid valve and diagram pump. We can use it. We want to develop accurate uh, model for low fluid flow control system from the real behavior, also from the experiment result. This is our big background of research. Our objective of this work is to develop identification model of control system from real experiment plan behavior of low fluid flow rate control. It is about control system model. You can see in this picture. We use sensor, flow meter sensor, especially Hall effect flow meter to measure flow rate as feedback element. And the system for actuator, we can use valve and pump. In this research, we use solenoid valve and diagram pump, but actuator we can compare
Tes 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 tes.
uh,
Hello hello.
the flow rate. Let's experiment and design model. It is
Yes, yes, it's okay.
use microcontroller
Tes tes.
to generate PM to the driver. Why we use driver? Because signal current signal from the microcontroller is very low, so we need driver to strengthen it to move the valve and pump. So this actuator can control the flow rate. We can use flow meter to measure this flow rate. This type of flow meter has effect flow meter use pulse. The output is pulse, so we can use um, the interrupt facilities in microcontroller, particularly digital input, to count the result of flow meter. You can see in the system identification that we use. System identification used to identify from the real experiment data. The output from this method is transfer function. transfer function, they are output comparing to input. The output of this patient activity is pulse and time. It is actually it is flow rate, because flow is equal to number quantity of volume divided by time. The pulse from equal to number of volume. So it is pulse and time is the flow rate for the output of the system. And for the input of the system, it is voltage, it is PWM signal, pulse width modulation. This is actually like microcontroller 5 volts equal to 255 bit and so on. So we can generate from this output to input to generate the model of control system in transfer function. So you can see in this is the picture of an experiment. The microcontroller. We use Arduino. The included here a driver. So they are in here flow meter. This is solenoid path is the palm. So in this picture, we are doing experiment and take some data. Let's continue. This is data, experiment, and the design method. Yeah. This is data for the palm. This is for the pulse. We can see from the palm there is signal 78% of signal. We can see the data is more unstable and but more become more stable. The pattern here, the red cycle, also the same. The red cycle, the pattern in this measuring result. But this is for 88% signal, larger signal. Contrastly, for pulse, the data is not good. Here, there are no pattern. So we decide to use the palm data because they have good and better ability to control the flow rate. The data, the step response here, we can track the data. We can use software. You can use MATLAB. There are system identification toolbook. You can use this toolbook to use system identification method. You can input the experiment data. You can then you can generate the transfer function control model, control system model. Here, the result. We can make a variation of the number of pulse and zero. I see this is the accuracy. 2 and 1, 2 and 1 and 1, 1 and 0, 2 and 0, and 2 and 2. Is the best. You can see the best is with the 2 pulse and 2 zero. It is the best. You can see the accuracy. We can simulate in the MATLAB, make comparison from the model and the experiment data. The result almost close, not only in the 7-8% PWM, also the larger signal, the accuracy is 95%, also close to 90%, 87% here. We make comparison. Let's continue to the conclusion. So, for identification model for low flow rate for below 80,000 milliliter per minute, or we can cite it is 4 liter per minute below this, and diameter is very small for the pipe, 8 millimeter. It is my definition for low flow rate as successfully built and presented in this presentation. They are for first time they are unstable, but uh, next they tend to be stable. You can see the data. It is for first time unstable, but tend to be stable. We can see it is need here need warming time about 70 seconds. Yes, almost 1 minute more to stable. Also from the data, diagram pump is better, the ability of control than the valve. Also the solenoid valve is not recommended to control the low flow rate. Also the number of pulls and zero is the better is 2 respectively. You can see from the table. The best combination is 2 and 2, number of pull and zero. Okay. And also the other type of valve, we said solenoid valve we can use. The ball valve, butterfly valve, we can use the other. In the next research, if you're interested, you can do it. So for closed loop algorithm, we can also use in the future, um, such as proportional, integral, and derivative algorithm or PID control. You can use maybe if you're interested in the next. So this is our presentation, our system based identification model of fluid flow rate. Thank you for your attention. Save, please save your healthy in pandemic of COVID-19. We must take care of ourselves and our family, our social, uh, and keep be happy and healthy. Wassalamualaikum warahmatullahi wabarakatuh. Bye bye.
Thank you very much for your presentation, Mr. Jalu. I would like to apologize for the quality of the video recording. It's the sound is quite low and the presentation is not in the presentation mode. But I think if some of the participants want to know more about the presentation, you may raise your hand and ask to maybe to ask to the presenter to explain more about the research. I see one of participant raise hand, Mr. Haris Septanto. I would like to invite you to say.
Okay, thank you, Ms. Latifah. Good morning, Pak Jalu. Thank you for your presentation. I want to. I have two questions. First question is, what the value of the time sampling you use? Because maybe I miss from your presentation, but I think it is important in the identification system. So the time sampling value, that's my first question. And the second question is, so you use the toolbox of MATLAB. Can you elaborate the setting of the toolbox, including what model you use for the identification system? Thank you very much.
Hello? Tes, tes, tes.
Yes, Mr. Jailu, you may answer the question directly.
Okay. I'm sorry for my recording is not for voice is not in good quality. Okay, thank you for Mr. Hari for your question. You asked about the time sampling. I use 1 second uh, time sampling for each data. I will share. Yes, the time is about uh, 1 second. Uh, I set it in the microcontroller to take every data for 1 second. Uh, I, I hope it is clear for you. And okay, for the setting of for I will show you the setting, a little setting of the uh, toolbox in the MATLAB identification model toolbox. Mm, I will share. Do you see? Yes. Uh, this is the MATLAB software, and we can see the toolbox.
I think you use
Yes.
the UI, the graphical user interface.
Yes.
I think there are some settings in the UI.
Oh yeah, yeah. Sorry. Yes, we can the toolbox. Where is the toolbox? Copy paste. Okay. Yeah, here is the identification toolbox, and uh, we can use time domain. For example, we can input the data here. It is from the workspace. The data we can input the data in from the microcontroller that we take the experiment. We can input the workspace, and we can input here from workspace and import the data here. Something like this, but
I'm sorry, Mr. Jalu,
yeah,
I
okay,
interrupt your
okay, something like this, yeah, yeah,
discussion.
yeah, yeah,
Yeah,
okay,
because we run out of time. And
okay.
is there any question from the participant? I do not see anybody raise their hand.
Or may
You
I
can
have?
ask me later, Mr. Hari.
Oh,
Yes.
okay. Okay, thank you very much.
Okay, yeah. Uh, this is quite interesting presentation. I have a very briefly question, very brief question about the warming time of your fluid flow. If I look at your result, the warming time is about 60 or 70 seconds. Do you think that the warming up is because of the constant flow rate that you apply? Or I mean, if you do the experiment with the flow rate increasing from 0 and then into the some constant value, maybe you may you can reduce the instability in the beginning of the time? Do you think that it's because of the jump of the flow rate?
Yes, I think every device have warming time. For my experience, every machine calibrator have a warming time. So yes, it is fluctuate from the flow rate how to they stable. So they have warming time to stable for a specific flow rate. The range and the small diameter of pipe. I think every flow rate have each unique warming time. I think.
Okay, thank you for your explanation. And once again, thank you very much for the presentation and your answer in this discussion session. Now we proceed to the next presenter. I would like to invite Mr. Suryadi from Research Center for Physics.
Good morning, everyone. My name is Suryadi. I'm from Research Center for Physics, Indonesian Institute of Sciences. Today, I would like to present our research on the comparison of social distancing violation detectors with graphical processing unit support. The background of our research is the COVID-19 outbreak that has been declared as pandemic by World Health Organization on March 2020. Meanwhile, the social distancing is claimed as the best transmission stopper in the present scenario. It is recommended that people should maintain at least 1 meter of distance among each other. Various social distancing measures have been implemented, such as travel restriction, border control, and also closing public places. To increase the effectiveness of this method, the existing technologies can be used to facilitating social distancing monitoring. So the objective of our research, we examine computer vision-based social distancing monitoring using one-stage object detection methods such as YOLO, YOLO-Tiny, and MobileNet SSD. The method aims to detect a person and then to measure distance between each person from the supplied video stream. Then we analyze those methods by comparing frame per second rate with and without graphical processing unit, the accuracy of detected person, and the obtained number of violations. In the existing image object detector usually can be classified into two categories. The first is a double stage detector, such as faster RCNN, and the second categories are single stage detector, such as YOLO and SSD. The double stage detector have high localization and object recognition accuracy, while the single stage detector can predict boxes from input image directly without region proposal step. So this method have high inference speed, so this method suitable for real-time devices. The YOLO method is one of state object detector proposed by Redmond et al. This method invented after faster RCNN, which have capability of performing real-time detection of image on webcam. These capabilities, because YOLO's pipeline predict less than 100 bounding box per image, while the fast RCNN using selective search predict about 2,000 region proposal per image. The second reason, YOLO executes the object detection as a regression problem. So a unified architecture can extract features from input images strictly to predict bounding box and class probabilities. This method continuously developed. The first development is YOLO version 2. This version proposed a new classification backbone, namely Darknet 19, which have 19 convolutional layer and 5 max pooling layer, which requires less operation to process an image which have high accuracy. And the next development are YOLO version 3, which propose a deeper and robust feature extractor called Darknet 53, which have more powerful than Darknet 19. The YOLO Tiny is a lightweight version of YOLO version 3. YOLO version 3 Tiny reduce the number of convolutional layer to about 7 convolutional layer, and the feature extractor are using the small number of 1 by 1 and 3 by 3 convolutional layer. YOLO 3 Tiny use the pooling layer instead of YOLO 3 convolutional layer with a step size of 2 to achieve dimensionality reduction. While the MobileNet SSD are built on SSD with use MobileNet for feature extraction and single shoot multi-box detector for determining the classification result. This method developed to improve the real-time performance of deep learning under limited hardware conditions. The first layer of the architecture is fully convolution, and the rest of the structure is built on deep-wise separable convolution. The final fully connected layer has no nonlinearity and fit into a softmax layer for classification. This slide shows the configuration of our social distancing monitoring system. It starts from video streaming as input, and then we conduct the object detection to detect the people. Then from the detected people, we compute pairwise distance among all centroids of the detected object. Then we convert the detected value to its actual physical distance and then compare to the threshold value. Then finally, we display the result. This is the hardware and software specification we use in our research. We use desktop PC, which have Intel Core i7 processor, and about 80 GB memory. For graphical processing unit, we use GeForce GTX 970, which have compute capability about 5.2. For operating system, we use Ubuntu 20.4 LTS, and OpenCV we use version 4.4.0. The video source is a recorded CCTV video of a pedestrian in downtown area in Oxford. This video has a format MP4 format, which consisted of 532 frames with a frame size of 700 and 392 pixels. In this slide, we have the summary of the performance result with and without GPU support from the tree of method. We can we can see clearly from the data in the table that YOLO version 3 have the very low FPS rate when the GPU support are disabled. But this value increased about 4 times from the previous FPS rate to about 12 when the GPU support are enabled. The data also indicate clearly that the YOLO version 3 Tiny have the lighter computational process, which show from the FPS rate that reach the about 21 FPS where the GPU support are disabled, and increase about 37 when the GPU support are enabled. For the mobile net SSD, it reached the FPS rate about 18 FPS where the GPU support are disabled. But the interesting phenomenon are happen when the GPU support are enabled. The FPS rate decrease the FPS rate decrease significantly up to 8 FPS. So the enable of a GPU not always increase the performance of the detection method. In this slide, we examine the detected people, detected violation, and detection accuracies. In this experiment, we take some frame from the video, frame number 50, 100, 150, 200, and 250. Then we compare the three methods to examine the detected people, the number of detected people, the detected violation, and the detection accuracies. From the data, we can see that the YOLO version 3 have the higher detection accuracies. It can see clearly in the frame number 100, where the YOLO version 3 can detect all image in the frame, while the YOLO Tiny only can detect 9 people from the 20 people, and the mobile net only can detect 6 people from 21 people. In the term of detecting violation, the YOLO 3 also have higher detected violation number. In the frame number 100, the YOLO version 3 can detect 14 violation, while the YOLO Tiny and mobile net SSD only can detect 2 violation. In this slide is show the visual detection of the frame number 100. We can see that the YOLO version 3 can detect the all people on the frame, while the YOLO Tiny and MobileNet SSD miss several people to detect. The people with red bounding box mean that distance between each other is less than 50 pixels, and the green bounding box refer to people with safe distances. In this slide, which shown the detection on frame number 250, also confirm that the YOLO version 3 have a higher detection rate, compared to YOLO Tiny and MobileNet SSD. And the conclusion of our presentation today, this paper have examined 3 object detector, YOLO version 3, YOLO version 3 Tiny, and MobileNet SSD, which used to social distancing monitoring. YOLO version 3 require heavy computational compared to YOLO version 3 Tiny and MobileNet SSD. YOLO version 3 shows the best detection accuracies in the exchange of heavy computational load. The use of GPU increase the performance of both YOLO version 3 and YOLO version 3 Tiny, but not for MobileNet SSD. That's all presentation today from me, and thank you for your attention.
Thank you very much for your interesting presentation, Mr. Suryadi, about object and violation detection. Now I would like to start the discussion session. Somebody want to ask question? I see Mr. Heru Susanto raise his hand. Please, you may ask the question directly.
Okay, thank you very much, Bu Arnida. Assalamualaikum, Pak Suryadi. I would like, Pak Suryadi, I would like to ask about the MobileNet SSD. As you mentioned that this method not really effective when GPU is running, is supporting of this method. Can you explain about that? Because on your result also that these methods of MobileNet SSD even cannot properly identify which one the violation within the object that we capturing. For examples, from your calculation, that's even the MobileNet SSD is only detect 5 something like that, 4, 5 something. Even the YOLO version 1 can, version 2 can identify by 14 evaluation, something like that. Because I was thinking that this method is something what happened in this approach. Thank you, Pak.
Thank you. Thank you for Mr. Heru for your good question. Can hear my voice?
Yeah.
Okay, thank you. Actually, we still not found the reason why the MobileNet SSD the performance not increase when the GPU are enabled. But from another references, we find that some people also find this phenomenon. So the FPS rate decrease when GPU are enabled when use the MobileNet SSD. But maybe just my guess, because this method are developed for constrained devices, maybe this not optimized for the use of graphical processing unit. but I still not find the actual reason. But in my guess, because the background of the development of this method, and for the term of detection violation detection, actually all method depend on the the detected accuracy to detect the people first. When the method can detect more people, then they can compute the probability to detect more violation. And this from, I'm sorry, maybe I share the data. Okay, from this table, we can see that the YOLO version 3 have the highest detection accuracies. From example, in the frame number 100, it can detect all people in the frame, while the YOLO version 3 Tiny only can detect 9 from 20, and the MobileNet SSD only can detect 6 people from the frame. Maybe we can take, here's the visual result of the method on the frame 100. In the YOLO version 3, the method can detect all the people, and from YOLO Tiny and MobileNet SSD, there is some missing people to detect. This are enough.
Is it image or real-time video, something like that?
The source is actually the video streaming from video, but the process is frame by frame. Okay. And when our code it capture video streaming, then process every frame, every single frame.
So meaning, if let's say when we take the frame number 1, yes, suddenly after a few seconds, then the object will be different between the previous one, yeah.
Because actually in our method is still some method like object tracking. So we still process a very basic approach. So we take to the frame a single frame. So there is when maybe for the first frame we detect the number of people, then we calculate the number of violation. Then maybe in the next frame, maybe the same object from the previous frame is still in the frame, something like that.
And maybe sometime also the next frame, maybe the object will be different. I mean, the appearance, the distance would be different, because sometimes this is the moving object.
That's right.
Be different frame by frame, something like that.
That's right. That's right.
Yeah. So meaning it is one frame that you're capturing, and then you calculation based on the frame that you choose, or something like that.
Yes, we actually process all frame continuously. Then we capture and save the data, something like that.
Okay.
Thank you.
Oke. Terima kasih Bu Arnida.
Okay, just briefly continue the discussion. I also wondering that you said that you detect the people continuously, but the accuracy, the best accuracy is from the YOLO version 3, but it has these advantages that it takes heavy computation. But do you think it's possible to implement the YOLO version 3 for real-time detection?
Yes, actually we We also try in another research. We use another method and hardware actually. Actually, the YOLO version 3, the performance can be increased by using GPU, but the software implementation actually in this research we use OpenCV to use the YOLO version method to detect the object. In another research, we because the using OpenCV is not quite high the frame rate, we also try using TensorRT. TensorRT is a framework from NVIDIA, so it will most suitable with GPU from NVIDIA. And in another research, we found that the increases of frame rate is higher than when we use the OpenCV, even we use the same YOLO version 3, something like that.
Okay, thank you very much for your nice explanation. I would like now proceed to the next speaker. So the next speaker is Ms. Rika Sustika from Research Center for Informatics. Please go ahead for your presentation.
Hello everybody, my name is Rika. I am a researcher from LIPI and now I am a doctoral student at School of Electrical Engineering ITB. Today I will present my paper with title Generative Adversarial Network with Residual Dense Generator for Remote Sensing Super Resolution. Remote sensing is the process for obtaining information about targeted object or areas by measuring its reflected and emitted radiation from a distance. Remote sensing imaging can cover larger areas than other methods of telemetry data acquisition, but the problem is low spatial resolution and very low in relation to the dimension of the sensed object. Higher resolution of remote sensing images can be obtained by using better sensing devices, but the cost will be more expensive. An effective way to increase image spatial resolution at lower cost is by using algorithm-based approach known as super resolution. Super resolution in remote sensing is important because it can assist the visual interpretation of images in remote sensing application, such as for surveillance, target detection, agriculture, land use mapping, meteorology, and so on. Super resolution is an algorithm that aims to increase the resolution of an image, increasing the number of pixels and providing better detail on the resulting image, as if the image is the result of an acquisition using a higher quality sensor. For many years ago, a number of traditional methods were used for super resolution. The simplest and fastest method is interpolation, such as bilinear or bicubic interpolation. In recent years, learning-based super resolution, especially deep learning with convolutional neural network, gets considerable attention and become popular approach, including for super resolution in remote sensing implementation. Super resolution method that proposed on this research is single image super resolution with deep learning-based approach. Here is the framework of the super resolution method. There are two main stages, training and prediction. For training, we need high-resolution image with corresponding low-resolution image. On this research, low-resolution image is obtained by downgrade the high-resolution image using bicubic interpolation. On the training stage, deep learning model is trained to analyze the statistical relationship between the high-resolution and its corresponding low-resolution image from a dataset training. On prediction stage, the trained super-resolution model is then used to predict high-resolution image from a set of low-resolution input image. Most of the super-resolution methods aim to maximize peak signal-to-noise ratio by minimizing pixel-wise mean square error between the super-resolved image and the target image. Measuring pixel-wise differences cannot capture perceptual differences between images easily. Therefore, higher PSNR does not always produce a perceptually better super-resolved image. The purpose of our research is to get the deep learning model that produces better perceptual quality and higher PSNR than state-of-the-art method for implementation on remote sensing super resolution. We propose GAN-based training with residual dense generator as our method. The first GAN-based training for super resolution proposed by Ledig et al. In 2017, known as SR-GAN or Super Resolution Generative Adversarial Network. GAN-based super resolution consists of two networks that complete each other, generator and discriminator network. The generator network generates super resolution image from low resolution input image. The super resolution image obtained from the generator and the corresponding high resolution image or ground truth image are fed into the discriminator to be assessed continuously until the super resolution image cannot be distinguished from the ground truth image. We update the parameter in the adversarial network using perceptual loss function that consists of content loss and adversarial loss. SR-GAN use ResNet as generator network and 8 convolutional layers as discriminator. Different with SR-GAN, our proposed method use residual dense network as GAN generator, and we use 10 convolutional layers with different number of filters in discriminator network. We name our proposed method as residual dense generative adversarial network or RDGAN. Here is the structure of residual dense network that use as generator on our RDGAN method. It's inspired by residual learning with dense connection network that proposed by Zhang et al. Input for the network is low resolution image. The network starts with 2 convolutional layers as feature extractor and then followed by some residual dense block or RDB. RDB consists of dense network with local fusion. The dense network allows direct connection between the state of preceding RDB and all layer of current RDB. Local fusion is used to learn features from preceding and current state effectively. Global feature fusion is used after the residual dense block to learn global hierarchical feature jointly and adaptively. After extracting local and global features, we use an upsampling network followed by convolutional layer to upscale the size of images. Discriminator network is a classification network that is used to discriminate the super resolution image from the ground truth or high resolution image. This figure shows the structure of our discriminator network on this research. The network starts with a convolutional layer with Licky-Relu activation function and then followed by 9 discriminator block or DBs. In the experiment, we use PatternNet dataset as training data. PatternNet dataset is remote sensing dataset that was collected from Google Earth imagery for US cities for remote sensing image recognition. The images on this dataset have 256 to 256 pixels in size, and the spatial resolution are ranging from 6.2 centimeter to 4.7 meter. This dataset consists of 30,400 remote sensing images, and we use 30,250 for training. For testing, we use 4 datasets. The first is Bandung dataset, the aerial photos for Bandung area. The second is Indo dataset, remote sensing images for Indonesian area that collected from Google Earth imagery. The third dataset is NWPU dataset, a remote sensing images dataset for scene classification. And the last is part of PatternNet dataset that didn't use for training. The training used 32 batches of size. All experiment was trained over 100 epoch. We employed 2 types of image quality assessment to evaluate our proposed method performance. The first is full reference image quality assessment, and the other is no reference image quality assessment or subjective metric. The objective metric compares the differences between the pixel value of the same position of the 2 images. We use PSNR or Peak Signal to Noise Ratio and SSIM or Structural Similarity as objective metric. The best performance is indicated by the largest PSNR or SSIM values. The subjective metric evaluates the image quality without any kind of reference image. This metric used to assess the perceptual quality and known also as subjective indicator. In this experiment, we use Nike score as no reference image quality assessment metric. Nike score is calculated by measuring a simple distance between the natural scene statistical model and the super resolution image. The smaller Nike score indicates better perceptual quality. Result of the experiment can be seen on this table. It shows the performance of remote sensing images super resolution for 4 times upscaling factor. We compare our proposed method with bilinear interpolation, bicubic interpolation, super resolution CNN, very deep super resolution, residual dense network, and super resolution generative adversarial network. This table shows that on the state-of-the-art methods, residual dense network achieves the best performance on objective metric, but the worst on perceptual quality index. Meanwhile, SR-GAN has superior performance based on perceptual index. On our proposed method, or RD-GAN, we combine the residual dense network with generative adversarial training, and the results shows that compared with SR-GAN, the PSNR and SSIM increase and Nike score is perceptual quality index decreased. SR-GAN and RD-GAN with VGG loss gives good perceptual quality because it looks on feature space that closer to perceptual similarity. Comparison between RD-GAN and SR-GAN can be seen also on this graph. The graph indicates that PSNR and SSIM of RD-GAN are greater than SR-GAN on 4 testing dataset consistently. Nike score of RD-GAN also smaller than SR-GAN on all testing datasets. It proves that the proposed method can improve the quality of super resolved image, not only on perceptual quality, but also on the PSNR and SSIM metric. Visualization of the experiment results shown on these 4 slides. These slides are example of the super resolved images with scale factor of 4 times on 4 testing data. This is for Bandung dataset. This result is in the dataset. This is PatternNet dataset, and this is NWPU dataset. We can observe from these figures that images reconstructed by bicubic interpolation and deep learning approaches without GAN training are vaguer or more distorted than super resolved images with GAN training. RD-GAN with GAN training generates super resolution image with better perceptual quality than others. As conclusion, on this research, we evaluated a GAN-based approach for remote sensing image super resolution. Residual dense network was used as generator to produce higher resolution image from raw resolution input image. The dense network with residual learning and skip connection leads to better PSNR and SSIM of the super resolved image. Applying VGG loss as content loss makes this GAN-based approach has better perceptual quality than other evaluated super resolution method. Our proposed method, or RD-GAN, outperforms SR-GAN in terms of full reference image quality assessment and perceptual quality evaluator on for testing dataset consistently. Here is our references. That's my presentation. Thank you for your attention.
Thank you very much for your presentation, Ms. Rika. I would like to ask Mr. Heru, do you want to ask question or this is your hand from the previous presenter? Because I see your hand raised, Mr. Heru Susanto. I think it's your hand from the previous presenter. So I would like to ask, is there any, yeah, Mr. Heru Susanto, do you want to ask question? Okay, is there anyone else want to ask question? Okay, because we run out of the time, I would like to ask a brief question to Ms. Rika. I see that in your research you choose 7 methods to compare. Can you explain why those 7 methods you choose?
The first method is interpolation, bicubic and bipolar and bilinear interpolation. That's they are a basic interpolation method, a basic traditional interpolation method. And then SRCNN or super resolution CNN is the first super resolution method for image processing. In image processing, super resolution CNN only use 3 layers for super resolution method, and then very deep super resolution use more layers than SRCNN. VDSR use 20 layers on the method, and then RDN as used on our proposed method use wider network than VDSR on SRCNN, and RDN give better performance on our evaluation. So that's the different methods become our for use as comparison for our proposed method. So all of the comparison methods have different approach for super resolution. Thank you.
Okay, thank you very much for your nice explanation. Now I would like to invite our last presenter in this session. The last presenter is Mr. Bernardus Sirenden from Research Center for Physics. So I'll give the frame for you. Please go ahead.
Hello, my name is Bernardus Sirenden. I am doctoral student from Faculty of Computer Science, Universitas Indonesia, and also researcher from Research Center of Physics, Indonesian Institute of Science. Today I would like to present a paper entitled of Dynamic Texture Analysis using Autocorrelation function of histogram similarity measure from Galois field texture representation of water flow video. The other 2 authors is Dr. Petrus Musanto from Universitas Indonesia and Dr. Sensus Wijonarko from Indonesian Institute of Science. Our motivation is to find several technology for measuring water surface velocity of river. The traditional way is dangerous since it needs to be in contact with the water. Camera-based measurement is much safer since the operator can be far away from the river. This is a sample of measuring water velocity using camera. Mr. Bandini installed camera in drone and use it to measure water velocity. The method that he used is particle image velocimetry. That means it tracks particle that flowing in the river. This is another example. Mr. Suji et al. Use space-time volume velocimetry to measure water velocity. It unlike Mr. Bandini, this method take advantage of change of brightness of water ripple. So in this method, volume are constructed from sequence of image frame, then use three-dimensional autocorrelation function to analyze this volume and transform the result to logarithmic scale and find peak in the distribution and determine the speed based upon the coordinate of the peak value. The space-time image volume velocimetry is based upon space-time image velocimetry by Mr. Fujita in 2012. In this method, virtual lines are constructed and image in the virtual line are used to construct a two-dimensional graph and use two-dimensional autocorrelation function to determine the speed. So STVV and STIV use autocorrelation function basically based upon Wiener-Kitchen theorem that say the autocorrelation function is inverse Fourier transform of power spectrum density. So STVV claim that the method is invariant to direction of water flow, but our preliminary research found that the STVV is affected by water flow direction. So our motivation is to improve STVV, and one of the inspiration that we found that from paper by Mr. Sipankar at 2018, where he used a Gauss field approach to represent image, static image, and rotate the image and try to classify the image using KNN, and he found that Gauss field is perform better than other representation. So this is how the transformation. We have a 3x3 neighboring pixel, and the center of the pixel transform using Gauss field addition. So Gauss field addition operation is basically is exclusive OR or XOR operation of binary value of pixel. So this center of pixel added counterclockwise with other pixels surrounding it, and the result is representation of the center image in the Gauss field. So this is our proposed method. We have a video, then we transform it using Gauss field, then we extract spatial feature. We have two options. We use histogram or normalized cumulative histogram, and we'll compare them, which one is better. Then we measure the similarity between the first frame and the end frame of the video using Euclidean distance matrix. Then we apply autocorrelation function to the simulative value, and we determine the periodicity of the peak of autocorrelation function graph. So this is our research step. We collect data set. We have to experiment. The first is virtual rotation, when video are rotated virtually using a software. Then we have actual rotation, when the camera physically rotated. Then we apply our proposed method. Then we use standard deviation to perform analysis. To find variability of result. This is our data set. The picture in the right top corner is the two video that we use for virtual rotation. The first video is we take using smartphone. The second video we use a video that exists in the internet. The first video is taken approximately the distance between camera and the water surface is 1 to 1.5 meter. Then in the virtual, we rotate them like the picture in the bottom right. And we select region of interest in the middle, and we apply our proposed method. In actual dataset, we rotate the camera 4 times, so we have 4 videos. This is running water, and we take 4 times with different rotation camera angle of camera. All the dataset can be found in our GitHub in below. So if you interested in to watch or to download, please do so. This is the Gauss transformation. Picture in the right, it is the result of Gauss transformation. In the left, it is the region of interest, the white box. It is ROE, or region of interest. This is the histogram and normalized cumulative histogram sample. In the right top, it is histogram. In the bottom right, it is the normalized cumulative histogram. And in the left, it is a sample of similarity distance result. So when we apply Euclidean distance and we get the result is the picture in the left is show the result, and we apply autocorrelation function, so you can find graph something like this. And if they have periodicity, the value of the periodicity can be determined. Yeah, this is our result. So the first table is the experiment using Gauss field, and the second table is the result when Gauss field are not used. So NS mean the number of successful experiment. So if the if the calculation or the computation found periodicity, then the number of NS in virtual experiment should be 37, because we rotate the video from 0 degree to 60 degree with resolution of 10 degree. So it is 37, and in actual experiment the NS should be 4, since we have a 4 video. And you can see in table 1 In histogram similarity measure or HS, we see in second video of virtual rotation the NS is only 21. That means it is less than it should be. And in actual rotation in experiment at 19 November 2019, we see only 3. Also, in when we apply normalized cumulative histogram in actual rotation at 19 November, we see TNS only 3 also. In table 2, we see that all NS in histogram similarity measure are less than it should be, and in normalized cumulative histogram, all the NS is appropriate, but if you notice in 19 November 2019 experiment, the standard deviation is bigger compared to other two. So we suspect something going on in the experiment at 19 November 2019. And we see in the region of interest there are flowing objects captured by the image, and we suspect this may be the reason why in 19 November 2019 experiment the NS is less than it should be, and standard deviation is bigger in NCHS column at table 2. So to have fair comparison, we only compare the result from normalized cumulative histogram similarity measure, and compare when we compare the Gauss field transformation and without Gauss field. We can see here the standard deviation produced by Gauss field for virtual experiment is always smaller compared to when Gauss field are not used. Even in second video, you can see the standard deviation is 5 times smaller. And but opposite thing happen in actual rotation. The Gauss field representation is have larger standard deviation compared to when Gauss field are not used. So our conclusion is normalized cumulative histogram perform better than histogram when as a spatial feature extractor, and Gauss field representation reduce variability for virtual rotation, but not for actual rotation. So we can conclude that Gauss field good for handling dynamic texture due to rotation, but not for other factor that may affect variability. Thank you for your attention. That's all that I can share.
Thank you very much for your nice presentation. Now I will give the time for all the participants if there is some question. Is there anybody want to ask? Okay, because we run out of time, I have one very brief question. If I look at your slide, there is an image that the river is not in line. I mean, it's not full in the research of interest. The river seems to be have an angle. Why don't you take the? I mean, take the photo so that the river is in line, I mean in line with the frame, so that you will have a larger research of interest domain.
Hello, are my voice can be here?
Yes, yes.
Yes, because when we taking the photo in the real world, it is very difficult because you have to stand in the water. So therefore, I cannot really line the camera. So yeah, so because it is difficult, the situation in the real world is not. That's why we have a virtual rotation, so you can imagine if we use maybe a drone or some kind of maybe a drone flying in the river, so that can be aligned, and we want to see the variability if the drone maybe do not align the camera with the water. Yes.
Yeah, thank you for your explanation. I think that's the last presenter, and before I close this session, I want to apologize that we are out of time. It seems that 5 minutes discussion is not enough for us, but all of you can contact the presenters directly to have discussion more details. Now I would like to invite all of the presenters and participants to turn on the video. We will have a photo session capture. If everybody is ready, I will count down. Miss Ayu Sabrina, Miss Vita Amalia, Mr. Risnandar, do you want to turn on your video? We are still waiting for other participants. But it's okay. I will count down. 3, 2, cheese. One more. I would like to ask Mr. Risnandar, Mr. Lindung, and maybe other participant to turn on the video again to take a photo. Three, two, one, cheese. One more. 3, 2, 1, cheese. Thank you very much. Then I will close this morning session. Once again, thank you very much for all the presenters and all the participants for joining this session. You may have some few minutes break before the next session. The next section will start at 10:10. Thank you very much.
Saya panggil aja. Oh.
Hello, good morning, everyone. This is the time for the second session for the last Icramet conference today. And before we start, I would like to invite for the 4 authors today. The first, I would like to invite for the name and presenter, Mr. Alfian Akbar Ghazali, for the code of S161.
I'm here.
Okay, thank you. And the next presenter is Mr. Aulia Khalil. Are you still here? S162. Oh yeah, you are still here. And the third one's Mr. Ray Ezra. The code is S163. Not yet. And the last one is Mr. Aminul Solihin for the code S164. Are you still here? Oh, not yet. Okay, before we start, I would like to introduce about this session for information and communication technologies application. The presenter time is 20 minutes, 15 minutes for presentation, and 5 minutes for question and answer. And before the last session, we would like to take for the photo group for our session in the paper session 16. And for the limited time, I would like to invite for Mr. Alfian Akbar Ghazali, entitled Pre-Development Analysis of Charter Framework, a platform to verify information authenticity. Time's yours, please, Mr. Alfian Akbar.
Okay, good morning, ladies and gentlemen. Let me introduce myself. I am Alfian Akbar Ghazali from School of Applied Science, Telkom University. Today, I would like to present my research entitled Pre-Development Analysis of Charter Framework, a platform to verify information authenticity. For the introduction, in this digital era, it is very easy to find information from many channels. The enormous information stream rapidly flows from these channels causes us incapable of reading all the content, let alone verify them. This condition potentially causes false information spreading. There are several websites which verifying them manually. For example, Google, Snopes, FactCheck, and PolitiFact. The common false information verification usually takes much time, effort, and prior knowledge. The prior knowledge that must be had to verify the information is good internet knowledge and good search engine skills. And this is the solution that we propose. By considering of all the existing problems that I mentioned previously, the author proposed Charter as a new solution to verify information authenticity. Charter is a seamless mobile app and web browser plugin to verify information authenticity. Charter can give a score for the news of the websites, social media posts, chatting app replies, emails, and any other text-based information we have. Information authenticity. Information flooding replaces information lacking as the biggest problem related to information dissemination. Previously, we have information lacking as a problem that we face. But now, currently, information flooding is worse than information lacking. It's very difficult in filtering a piece of authentic information rather than finding related information itself. A piece of false information could break the trust between people or even potentially cause horizontal or even vertical conflict. Spreading false information may also significantly damage the reputation of some business or organization. And here we come propose Truther. Truther is a framework of an information authenticity verifier system. Truther has two main front ends, a seamless background app and web browser extension. The main idea of mobile app is installing Truther as a background app. Thus, users don't have to open a Truther app to verify information authenticity from their daily apps. For example, when in the middle of reading my text at WhatsApp, I don't have to switch to Truther app to verify the information of the group post. I just need to copy for Android OS or share for iOS OS the text, link, or even image, and just pass information to Truther. So we don't have to open the Truther app itself. It runs in the background. This is Truther mobile app design. We can see we just have to copy and then show the score. And for the implementation of Truther mobile app, it's like this one. We have Truther score at the center, and we have 4 categories which build a final Truther score at the center. We have 4 categories: content, source, media, and community. And if we disappoint with the result, or we satisfy with the result, we can give rate at the bottom of pop-ups. We can give the rating from 1 to 5 stars. And this is the design of web browser plugin. We just have to click the web browser and they will show the Truther score of the website. Okay, and this is the implementation of Truther web browser plugin. The UI is quite similar with a mobile app, but this is more clean design and more detail we have in this web browser plugin implementation. We have total Truther score at the center, top center, and the details of each categories, which is divided into 4 categories, at the bottom of Truther score. We have content, we have source, we have media, and community. We also can give rating for the result of the Truther also. For the false information scoring, the final score itself is a function which accumulates all other scores by using a weighting mechanism. We have alpha, beta, gamma, and theta, which takes role as a weight of the content, source, media, and community scores, respectively. The formulation of the final score is shown below. Final score is equals to alpha multiplied by content plus beta multiplied by source plus gamma multiplied by media plus theta multiplied by community. And these scores will build a final score, which will be shown in the center of Truther app. This is the Truther framework. Truther core engine contains 3 main subsystems. Truth Scorer, or Semantic Verifier, Debunker Aggregator, and External API. We can see in the left side, we have web browser plugin, or mobile app, or even personal custom application, which are connected to Truth API. And then Truth API will connect to Truth core engine, which is consists of Debunker Aggregator, Semantic Verifier, and External API. Debunker Aggregator aggregates many website debunker in the internet, for example, snopes.com, turnbackhoax.com, .co.id, truthorlie.com, and politifact.com. And for semantic verifier, it combines two main subsystems. The first one is content truth scorer, and the second one multiple language adapter, which will be enabled truther to verify the hoax, the information authenticity from other languages. And the third subsystem is external API, which consists of Google Machine Learning, Azure Cognitive API, DuckDuckGo API, and Web of Trust API, which will validate the authenticity of source of the website. Okay, and for the detail, this is the flowchart of Truther framework. From start, the user sends input, and then API adapter will receive the input, and it will translate input into N languages. And then we have search engine recommendation, summary recommendation, and add recommendation to API response. And parallel with search engine recommendation, we classify rating using semantic verifier. We get the language model score, get hoax database model score, and get source weighting score. And then for the second one, we match input with debunker aggregator. The third one, we get source from trustworthiness with WOT or Web of Trust API, and analyze metadata user using Google API. These four candidates, these four scores will be calculated for the final score. And then we add the rating to API response. After that, we send API response, and user will get rating and recommendation. This is the experiment for Truther pre-development. Because before conducting Truther testing and development, we run a pre-development analysis to test our initial assumptions and hypotheses. After formulation of our assumption hypothesis, the experiment tools and target segments are defined. This is the Truther experiment overview. From the experiment start, we split into two surveys. The first one, online surveys, and the second one, offline surveys. For the online survey, we use Google Form for pre-test. So before we conduct the experiment, before we presented our solution, we spread the Google Form for pre-test first to validate the problem. And after that, we give the respondents promotional and tutorial video YouTube link, and they will see the promotional and tutorial video. And we also give appetize.io link for real demo app experience. And after that, we share the Google Form for post-test. And after that, we collect and analyze feedback, and then we follow up. That's for the online survey. For the offline survey, we divided into two, field survey and private discussion to organization and company. For field survey, we also show the promotional and tutorial video. And then we show the real MVP demo app, not appetize.io, but real MVP demo app. After that, we share the questionnaire, and we collect and analyze the feedback and then follow up. That's also happen for private discussion. We show them promotional and tutorial video, and then real MVP demo app to give experience to get the feeling for using Tutor app. And then after that, we also give the questionnaire verbally. So we have a question and answer session. And after that, we collect and analyze feedback. And then we follow up. And we have three main hypotheses to be validated. The first one is hoax is a serious problem considered by social media and internet users, according to close-ended survey results. The second one, Twitter is handy solution to verify the reliability of information or posts and extremely testable via manual research to prove its value and accuracy. The third one, Twitter is ready to be developed and have potential market adapters. And then we use three experimental tools. The first experimental tools are Google Forms for online survey and questionnaire for offline survey for pretest or problem identification and also for post-test MVP feedback. The second tool is promotional video for an introduction and workflow explanation. And the last one, Twitter app and plug in MVP and upload it to appetize.io for real online experience. And for the target segment, we segmented our targets into three. The first, internet and social media users. We target 500 respondents. This is the largest percentage of Twitter users. They are important for generating gold training dataset and fan base. The second one, business users. We target 10 companies. This segment is our main money revenue. The third one, non-profit organization. We set the target into 5 organizations. This segment is our partner for endorsement and moral support. And then this is the experimental result. From the chart, we can conclude that the distribution of our respondents are, for the ages, more than half, or around 55.62% of our respondents are 26 until 50 years old. The second age range is 19 until 25 years old. For the second hypothesis, we want to validate whether Twitter is easy to use or not. And the result is 97% satisfied with Twitter workflow, and with about 13% asked for design improvement. The third hypothesis is Twitter is ready to be solved. We offered 3 package plans. The first one is free, and then paid, business, and partner. This is also free. Additional insights. There are at least 4 potentially early adopters which need to be followed up. Some potential features are identified, such as recommendation and feedback. What could not be tested? Twitter average, response rate, and non-functional capabilities. Okay, this is validated learning result. For prior knowledge survey result, we can get combine very serious and serious. It's around 93%.
I think your
Only
slide is more
6.71% that
and over
see that hoax is not
so
a
maybe
serious
you
problem.
can stop your slides because your time remind 1 minute again for this time. So for this session, any question from for this presenter entitled pre-development analysis of Charter Framework, a platform to verify information authenticity, by Mr. Alfian Akbar Ghazali. Any question? I would like to check your question or comment or anything else maybe. No question, but I have one question for you. Based on the linguistic approach, the semantic text has an effective processing of query that are written in natural language processing, right? And then, however, the semantic text has a problem such as it cannot consider the domain of query. So sometimes it gets a low precision, maybe something like that in the ratio. What do you think about this problem in semantic text? Could you answer? Could you hear me? Alfian Akbar. Hello? Hello? Alfian Akbar. Could you hear me?
Yes, I'm sorry, I have a connection problem.
Okay, sorry. Yeah, please answer my question, my short question.
I'm sorry, can you repeat the question because I cannot hear?
Okay, once again. Based on this linguistic approach, the semantic text has an effective processing of query, okay, that are written in natural language processing. However, the semantic text has a problem such as it cannot consider the domain of query, maybe something like that. And then so sometimes it gets a low precision ratio. What do you think about this problem in the semantic text?
Thank you for the question. Actually, yes, that's why we also included our users' input. So if you see in the flowchart of Truth Framework, we have two approaches. The first one, we build our model based on our data sets. And the second one, we also build the model based on user inputs. So the larger user, it will be smarter our machine learning will be. So we believe that when the times go on and our application was implemented, our NLP, our machine learning will be smarter and smarter.
All right. Anyone? Any question, comment, or anything else maybe? Please, coming. Mr. Heru or Mr. Hari? All right, but for this session, your time is over. So thank you very much and give applause for the presenter, Mr. Alfian Akbar. Thank you very much, Mr. Alfian Akbar.
Thank you.
And then the second presenter is presented by Aulia Khalil, the entitled Theoretical Model for Continuous Usage Intention of mHealth Application. And time's yours for Mr. Aulia Khalil.
Good day, ladies and gentlemen. My name is Aulia, doctoral student from Binus University, Jakarta, Indonesia. Since we are still in pandemic situation, so I hope you, your family, and your beloved one are doing well. Today, I'm going to present my paper with title Theoretical Model for Continuous Usage Intentions of Mobile Health Applications. So first thing first, why we did this research and why it is important. In this day and age, more than 300,000 mobile health applications are available in the market. And by 2018, there were over 40% users used mobile phone to manage their health, but more than 30% users uninstalled their mobile health applications within a month of download. Why this uninstall issue need to be addressed as soon as possible? Because approximately company lost $33,000 per month due to uninstalled app. Also, mobile health applications is worthless if user doesn't use the app continuously, because they will not be able to achieve their main goal, which is improving the quality of life. The next question is, why user uninstall their app? The reason is, it depends. It can caused by the poor service quality, the price is too high, it's hard to use, and so forth. But basically, users stop using the app because the app failed to meet their expectations. Therefore, we did this research to understand factors affecting continuous user intentions of mobile health applications. Similar research has been conducted in several countries, such as Bangladesh, Malaysia, China, Korea, but we rarely find the research that is conducted in Indonesia. The next section we want to talk about is theoretical foundations. In these sections, we will talk mainly about the definition of mobile health and the definition of continuous user intentions. We define mobile health applications as the utilizations of mobile devices such as smartphone for delivering various kinds of health services. While continuous user intentions we define as the intentions of users to keep using their app after accepting it. The next section we will talk about is the theoretical model that we will propose in this research. But before that, we want to talk about what is the best model that we use to construct our model. We use Information System Continuous Model, or ISCM, to construct our model. ISCM is developed by Beta Surgery to understand user post-adoption's behavior. Why we choose ISCM as our best model is because, first, it is the most popular model that used by researchers to understand the post-adoption user behavior. Second, ISCM has been proven accurate to predict user post-adoption behavior. The next question is there a proven model that has been developed to understand continuous users' intentions of mHealth applications? The answer is yes, it is. Actor et al. Has been developed a model for understanding continuous user intentions of mobile health, and we call it as ISCM in mobile health. Actor incorporated trust and service quality to its model, and the model has been widely used to understand mobile health post-adoptions. That's why we will use Actor's model as the basis of our theoretical model. This is our proposed theoretical framework. As you can see, we expand Actor's model by incorporating perceived ease of use and perceived fee. Both new constructs have been proven give positive impact to continuous usage intentions. By total, we have 16 hypotheses that need to be tested. The next sections we will discuss about the methodology that is used in this research. First, data collections. We collected the data by distributing online survey to mobile health application users in Indonesia. Survey was distributed through social media from July 31st until August 8. Total respondent was 105, with 12 respondent is invalid and 93 valid respondent. 62% of our respondent is female and the rest is male. And most of our respondents had used the app for between 1 until 3 months. Collected data were then analyzed using PLS-SAM. In this research, we use 0.5 significance level. And before doing a hypothesis testing, we conduct 2 evaluations, which is measurement model evaluations and structural model evaluations. Next, we will discuss about the result of our data analysis. Before we do a hypothesis, we conducted a measurable model evaluations. The measurable model evaluation result work as follows. All constructs have auto-loading value and composite reliability value above 0.7. Also, all constructs have AV value above 0.5. Therefore, we can conclude that the measurable model is valid. The next evaluation we conducted is structural model evaluations. All constructs have VIF value below 10, while path coefficients only satisfactions to continuing user intentions has negative value. And for R-square value, we have one construct substantials, two construct moderate, and the rest is low. After performing the evaluations, then we perform a hypothesis testing. The result, 5 out of 16 hypotheses were rejected. Only perceived V and perceived usefulness were proven have positive impact to continuing users' intentions. Confirmations and perceived ease of use also prove has positive impact to perceived usefulness. So the next questions, what does the result mean? Only perceived usefulness and perceived fee were proved positively impact to continuous users' intentions. Since this research was conducted in Indonesia, we can see that user will continue use the mobile health applications if it is useful to them and have a reasonable price. Users in Indonesia tend to ignore other factors like service quality and trust. Since perceived usefulness was proved positively impact to continuous users' intentions, then we want to see what construct have positive impact to perceived usefulness. Confirmation and perceived ease of use are constructs that were proven have positive impact to perceived usefulness, meaning when the app is easy to use, user will be able to operate the application easily, and they will be able to explore all features that exist in the app. Also, knowing user initial expectation is important because the higher user expectation is, the more difficult to satisfy them. Here we come to the end of these presentations. So the conclusions of our research as follows. From the discussion before, we can conclude that perceived usefulness and perceived fee are the two factors that proven have positive impact to continuous usage intentions. Also, confirmations and perceived ease of use were proven give positive impact to perceived usefulness. Hence, people will continue to use their mobile health as long as it's useful and have reasonable price. Our research gave contribution both for academic and practical. From academic side, this research is proposing the new model to understand the factor affecting continuous user intentions of mobile health, so it can be used for future research. Also, this research was conducted in Indonesia. It will give new knowledge about user behavior in specific country. While for practical, the result of this research can be used as a guideline to improve the app quality to reduce number of uninstalled apps. Several limitations of this research as follows. The object of the study is mobile health applications in general, while in fact, there are so many mHealth domains. So it will be better if the next research focus on particular domain. The next limitation is we only can reach about 93 respondents. So it will be better if the future research can increase the number of respondents to get more comprehensive result. That's all my presentations, and thank you for your attention.
Thank you very much to Mr. Aulia Khalil. The times is still remain 1 minute, but for the question and answer, you have 6 minutes totally. So anybody here for the question, comment, or anything else, maybe please coming. I check in the right hand, please, right hand. Oh, okay, Mr. Hari Septanto, your question is.
Thank you, Mr. Moderator. Thank you, Mr. Presenter, for your presentation. I have two questions. First question is, this application should be have a society or maybe age level target you intended. How mechanism or strategy to distribute the questionnaire such that you can get the target society? Uh, that's my first question. And the second question, I'm curious about the valid and invalid respondents that you state. How to define the valid and invalid respondents? Thank you.
Thank you, Mr. Hari, for your questions. To answer your first questions, yes, we targeted certain age to answer our questionnaire by targeting. We use like we grouping our distributed of a questionnaire by by uh, by grouping like how can I say this? I want to distribute this questionnaire to my college, which already the age range is between 21 until 30. And the second one, I want to distribute this to the person who already in the age of 35 and above. And I created this kind of list. So I'll distribute it to that group, which consists of the certain of age. And for the second question is we to determine valid and invalid response, we add some trap questions like have you used the app and what the app that you use, and we put some invalid app, and we also put some trap question like have you used this feature, have you used this feature, just to validate this user is really used the mHealth application. So after we collected that questionnaire and we filter out that this questionnaire isn't valid because some respondent answer like I using the app for 1 month, but they use the app that not mHealth, so yeah, it's invalid. Yeah.
Okay, thank you. Thank you very much for your elaboration.
You still 3 minutes. Any question, comment, or anything else from others? If no, I have one question regarding to your method or the partial least square structural equation modeling, PLSM, right? In my experience, I have some problem with how to aware of some weakness of PLSM. For example, this is the problem of multicollinearity if not handled well. And the second one, it may create large of the mean square error, MSE, in the estimation of path coefficient loading, something like that. The first is problem in multicollinearity if not handled well. And the second one, the big problem or large value in the mean square error, MSE, of the estimation in the coefficient of loading. Yeah, maybe you can answer or justify what's the problem to handle this one.
Yeah, actually, I'm not familiar with this statistical problem, but I know that there is some problem with PLSM like multicollinearity, which is we need to use like Herman test to retest our result for the PLSM. Yeah.
Okay, that's right. Okay, thank you for your answer. And actually, your time is over time, but thank you very much for your answer and presentation. For Mr. Aulia Absari Khalil, give applause for Aulia Absari. Thank you very much.
Thank you.
Okay, we go to the next presenters. To Mr. Ray Ezra from Bandung Institute of Technology for entitled web apps designed for surface plasmon resonance signal processing. Mr. Ezra, are you still here? Please, the time's yours.
Check. Yes. Hello. Check.
Yes, okay.
Yes. Hello. Check. Okay. Hello, my name is Ezra, and now I'm going to present our team's paper project about web app design for surface plasmon resonance signal processing. Here are the outline of topics for this presentation. First, we are going to talk about the introduction. Next, we are going to talk about method of this paper's work. Next, we are going to talk about results and discussion of this paper's work, and the last is conclusion. Okay, we know that the world is facing a serious problem caused by COVID-19. The world, including Indonesia. COVID-19 is a dangerous disease caused by a virus which can transmit really fast from an infected person to another healthy person, either by direct contact or through contaminated objects. One way to suppress this virus transmission is by doing massive examination. Currently in Indonesia, there are two major categories of COVID-19 examination. The first category is molecular-based assay by using PCR, or most people know as the swab test. And the second major category is the serological and immunological assay by using antibody, or most people know as the rapid test. These two methods are still insufficient to carry out massive and comprehensive examination. So, it is necessary to develop an alternative way to detect COVID-19 in Indonesia. So, we can do more examination and suppress the virus transmission even further. Here are the pictures of the two major categories test, two major categories COVID-19 examination. Currently, surface plasmon resonance as an alternative method to detect COVID-19 is being developed by collaboration of Pajajaran University, Institut Teknologi Bandung, BPTT, and Tekad Mandiri Cipta Company. SPR is basically an optical technique to detect a molecular interaction between two different molecules. These two different molecules will the interaction between two molecules will cause a change in refractive unit index, and by using this refractive unit index, you can analyze the presence of a virus in a substance. Generally, SPR data needs to be processed because of its outliers and noises. However, normally SPR data are processed manually, which is time-consuming and ineffective and inefficient. So, we are proposing a web-based application designed to process and visualize SPR data. Moving on to the next section. For the method of our work, we are using requirement diagram. The requirement diagram for the web app design consists of three requirement subsystems. The first subsystem is signal processing algorithm. The second subsystem is data visualization. And the third is user interface. In this paper and presentation, we mainly focus on the data visualization. Data visualization requirements can be derived further into two requirements. The first is user input, and the second is interactive plotting. On this user input requirement, the user needs to be able to upload or input SPR file or SPR raw data. Then the user needs to be able to choose the baseline method, either choose the baseline method manually or automatically. And the third is the user needs to be able to input the sample's name and concentration. On the interactive plotting requirements, the user needs to be the final graphic, the final result needs to be able to show legends on the graph, show labels in the graph, and use some tooltip for the graph. So next is result and discussion. For the first step of our work is data collection and storage. In this step, the user inputs the required data. The required data includes SPR file, SPR raw data. This is the example of an SPR raw data. The next, user needs to be able to select the baseline method and input the sample's name and concentration. This is required because it is related to the next process. After the data is input by the user, the data are then transmitted to the HTML to a cloud storage. After the data is stored to the cloud storage, the data then can be processed further with Python. Next step is data exploration. For the processing with Python, is required to remove noises and outliers. This process is using the spike function and Savicii Golay filter. After the outliers and noises are removed from the SPR data, the data can then be used as input for predicting baseline. Next is data representation. In this step, the data is represented or visualized into a graph. As you can see here, the graph here, this is the graph of the SPR data. Okay, the x-axis here represents the time, and the y-axis represents the refractive unit index. As we mentioned before on the requirement diagram, the interactive plotting, this graph needs to be able to show legends. As you can see here, here is displayed legends, channel 1 and baseline. You can see the channel 1. The result is the blue line here, and the baseline is the red line here. Then the interactive plotting able to show the labels. These red ribbons here, as you can see here, are the labels for each sample. The sample's name and sample concentration that the user has input before is used as label here. If we zoom in here, we can see the sample's name, also the sample's concentration. Also, the sample's average refractive unit index reaction. And we can see here there are interactive tooltips on the top of the graph. As we mentioned before, user able to choose methods for baseline prediction, either manually or automatically. If the user choose to predict the baseline manually, user needs to select 10 points from the graph, and then the 10 points are used as input for the next algorithm to predict the baseline. But if the user choose to predict the baseline automatically, then the algorithm will choose its point itself, and the user needs no further input. The algorithm will detect or predict the baseline instantly or automatically. Here, for the manual baseline prediction, we use genpot function from matplotlib library on Python. Meanwhile, on automatic baseline prediction, we use scikit-learn for choosing the point itself. Next, after the data is visualized, here the data is represented. The data is then rendered to HTML with bokeh, so the web can display the data. After using this rendering technique, this data is now appears dynamical on the web, not instead of statical. Okay. Next is conclusion. Summary of the paper. The first web application for SPR signal has been successfully created and able to analyze SPR sample data within minutes. The second, web application data visualization requirements derived into user input and instructive plotting. Third, web application use matplotlib to predict baseline manually and use scikit-learn to predict baseline automatically. And the fourth, web application mainly use bokeh to visualize data dynamically on the web. Okay, thank you.
All right, thank you very much to Mr. Ray Ezra from Bandung Institute of Technology. And anybody here, any question, comment, or anything else maybe? Please, welcome. Oh, from Mr. Esa Prakasa. The time is yours for the question, please. Mr. Esa.
Okay, thank you, Dr. Snandar. Thank you for the presenter. I have one question. I think the interesting part is you said you use bokeh for visualization, for the diagram visualization, right? My question is, why do you need add bokeh function to visualize the diagram? Because since I know the bokeh is normally used to adjust the focus, the focus area of an image, means we can have multiple focus deep in a single image. So what is the benefit by applying bokeh to visualize the diagram? Thanks.
Okay, please, Mr. Ray Ezra, for your answer or comment.
Okay, check.
It's okay.
Okay.
I hear you.
Okay, thank you. So here the bokeh here is different. So the bokeh we use in the application here is the name of the Python library. It is necessary to use this bokeh library or bokeh Python package, so we can display or we can show the graph into the web dynamically. The main problem for this web application here is to link the Python algorithm to the graph to be displayed dynamically. Normally, if we use Python, the graph will be shown static, so we can use tooltip or we can see the cursors on the graph. But with this Python package, we can use tooltips and we can use cursors on the legends, etc. So this bokeh, to answer your question, this bokeh is different with the lens technique as we normally know, but this bokeh is the name of the Python package or Python library we use. Okay, I think that's all.
Maybe another confirmation. Is it not enough if we use some kind of library such as matplotlib, for example?
Yes, it is not enough because matplotlib, the matplotlib library or matplotlib package can't render the graph into the web, because to display the graph on the web is we are using two different language, Python and HTML. So it needs to be linked between this Python language and the HTML language, and Matplotlib doesn't support this function. So only
yeah.
Yeah.
Okay, thank you for your answer.
Okay, thank you, Mr. Esa and Mr. Ray Ezra. And you still remind 5 minutes for question and answer. Any question? Oh, okay. I invite to Mr. Hari Septato for next question. Okay, please, Mr. Hari.
Okay, thank you very much, Dr. Risnandar. Mr. Ezra, my question is similar with Dr. Esa actually. My question is, why you choose Bokeh? Why not, for example, Grafana? And why you choose Matplotlib? Why not choose the other? And why you choose scikit-learn? Why you prefer? What your consideration? Why you choose that three package?
Okay.
Thank you.
Okay, first. Okay, thank you. To the reason we use this Bokeh package is because we think it is the simplest package we can use to embed or to render this graph into the web dynamically instead of the other package. We think that the other packages are too complicated. This Bokeh is easier for us to use and easier graph, simpler than dynamical graph. So no need to other complicated functions. We don't need anything else from the requirement diagrams. This Bokeh fully supports this requirement. And this Matplotlib, we use Matplotlib so we can choose, as we mentioned on this presentation, for the baseline method manual prediction, we need to choose 10 functions on the graph. And this function only supported by the Matplotlib. And when we were doing this project, we didn't found any package that can support this function. I mean the function that we can choose 10 points from the graph. Only Matplotlib can support this function. So we use this G-input function from the Matplotlib package. And for the scikit-learn, actually this is a discussion for the next paper, next presentation after this presentation, which is talking about the algorithm itself of the data visualization.
Mr. Hari, that's it.
Oh, yeah. I have one more question.
Okay.
What about the database?
Okay. So for the database, we are using Firebase storage. So for the further explanation, we gather the information or the data based. We gather the files and gather the data such as the patient's name, the date of examination. For such data like patient name, date of examination, and the result, we use Firebase real-time storage, so it is easier to process. While for the files, we use Firebase storage. It is necessary to use the Firebase storage because by uploading to the Firebase storage, it can be downloaded to the Flash, so it can be processed by the algorithm and the Python algorithm. So the data is doesn't need to be downloaded to the server. We use the cloud storage.
Okay. Thank you, Mr. Ezra.
I think the time is enough for Mr. Ray Ezra, and give applause for a presentation of Mr. Ray Ezra. Give applause. Thank you very much for interesting presentation, Mr. Ezra. And finally, we have the last presenter for Mr. Aminul Solhin, entitled Signal Processing Algorithm for Pre-processing the surface plasmon resonance signal response. The time's yours to Mr. Aminul Solihin. But before we start, don't forget to fill out the attending you are here in the chat box. Please fill out.
Assalamualaikum warahmatullahi wabarakatuh. Allow me to introduce myself. My name is Aminul Solihin. I'm from Biomedical Engineering Department, Institute of Technology, Bandung. I'm going to present the signal processing algorithm for the pre-processing the surface plasmon resonance signal response. Here are the outlines of my presentation. Firstly, I will explain about the introduction, followed by the methods and results and discussions. COVID-19 is a highly contagious disease caused by SARS-CoV-2. This virus is airborne and could survive in the droplet suspensions up to 16 hours. This makes the spread of the virus is extremely hard to control. The testing process is very essential to tackle the virus spreading. Based on the WHO, the recommended test ratio for each country is 1,000 tested over 1 million populations. The PCR, or polymerase chain reaction, is used as the gold standard for the COVID-19 testing due to its ability to amplify the genetic molecules. But it takes a long time to get the result. The testing process can be fully relied on the PCR since we risk with the fast spreading of the virus. Thus, rapid test is then used for the alternative test, but it has lower sensitivity and specificity compared to PCR. Therefore, it's necessary to improve the testing process in order to get accurate results in short period. As an alternative, the optical-based biosensors can be utilized to overcome this issue. Commonly, they are widely used for the detection of molecular binding due to their advantages, such as high sensitivity, specificity, label-free, and real-time. In this case, the surface plasmon resonance, or SPR, is an optical-based biosensor that can identify the interaction between antibodies and antigens. Although it's a promising alternative test, the SPR raw data output is noisy, and the vendor-provided software cannot be a direct identification of the SPR signal response. Therefore, I proposed a signal processing algorithm and automatically to remove the noise and simultaneously identify the SPR signal response. Here are the methods. First, substrate and sample preparation. The substrate slide is used in the experiment is 20 millimeters times 20 millimeters times 1 millimeter glass coated with evaporated 45 nanometer thin film gold, which has a 1.61 of refractive index. The IgY, or immunoglobulin Y antibody, was used in substrate preparation. In the immobilization process, firstly, 10 millimolar MPA solution was applied to the surface of gold substrate and followed by 0.1 millimolar EDC and NHAS. After that, IgY was dropped to the surface. 1% BSA of bovine serum albumin was spread on the surface drop by drop. Later, the gold substrate was incubated in the ambient temperature and pressure for 90 minutes. Then it was flushed by immersing in the PBS of phosphate buffer saline buffer solution. The negative IB and AI and positive RBD and spike sample were prepared in the PBS buffer solutions. And the concentration of sample used can be seen from this table here. Now we move to the data acquisition and pre-processing. The Nano SPR8 device was used in the data acquisition. Firstly, the device was turned on for approximately 30 to 60 minutes before the data acquisitions. The prism glass was positioned in the holder, and that immersion liquid, which has same refractive index as the glass slide, is applied on the top of the prism surface, followed by placing the bare substrate on the top of the surface. It's necessary to run the device for about 30 minutes with a buffer to remove the signal drift. Generally, the data acquisition was done to note the response of the sample towards the buffer of the baseline, whether ascending, descending, or no response at all. Each chamber of nano SPR8 was irrigated with a sample. The sequence of running processes was a buffer, sample, and followed by buffer again. The first buffer was meant to be the reference line to calculate the response of the sample, and the second buffer was for determining the dissociation of the antibody and antigen's molecular binding. The signal taken was a non-periodic square wave and disturbed with the outlier spikes, continuous noise, and signal drift. Before calculating the sample ascending from the baseline, the outlier spike were removed by comparing the array with neighboring data. Savitzky-Golay filter was used to smooth the signal due to its ability with polynomial function. Buffer response signal or the baseline and sample response signal were separated using dynamic programming search method, an offline change point detection function in Rapture Python package. Now I'm going to talk about result and discussion on the pre-processing part. The pre-processing was implemented in 3 steps. First is spike removal using this spike algorithm, averaging with neighboring data using moving average filter, and smoothing using Savitzky-Golay filter. In the first step, the despike algorithm, which is adapted from the Raman spectra spike removal, is employed to remove the unintended positive signal spike. The despike algorithm calculates the median and median absolute deviation to determine the modified z-scores, which contribute to the resolving spike signal. Then the spike remove signal is filtered using moving average. This filter is commonly used in the digital signal processing due to its ability to reduce random noises while preserving the distinct step response. The last, a Savitzky-Golay filter is utilized to smooth the signal. It is able to smooth the data in polynomial order using least square smoothing signal. Here are the result of the pre-processing from the raw data, and then spike removal and moving average filtering, and finally, signal smoothing using Savitzky-Golay filter. As we can see, the difference, the signal is smoothed compared to the raw data. Now we move to sample location detection. In this stage, is implemented in Python using the Rapture package and using the dynamic program search method or DBSM. This method could solve nonlinear integer problems. Then the change points obtained are used as a reference for data segmentation. The detected change points are used as the point to separate the baseline and sample. The algorithm at this stage was tested using 2 data where the result obtained can be seen from this figure. As we can see, the blue region is the baseline, the first one and the last regions, and in the middle, the pink color region is for the sample signal. The orange lines was the manually input ground truth were manually inputted by the expert, and we can compare with the algorithm to find the error, compare DPSM or the algorithm to the ground truth, which is manually inputted by the expert. As we can see, the error is slightly high with 13.8%, 12.5%, 9.9%, and lastly 7.7% in error compared from DPSM with the ground truth. And the last is sample location detections. Change point obtained before in use to exclude the sample response signal region, and the remaining data or the buffer response signal region are used for training data in the polynomial regression functions. from the left figure is for the baseline detection. Is the data training for the algorithm to detect the baseline to exclude it from the signal. And then the excluded data is used for the baseline predictions. After that, this baseline prediction can be used to calculate the ascending, which is the distance between this signal or the sample toward the baseline predictions. This ascending signal is very essential to determine whether this sample is positive, negative, or unknown. Because from this study, we have aimed to develop the algorithm which is sensitive enough to detect the ascending from the signal. Okay, I think that's all for my presentation. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much for your interesting presentation from Mr. Aminul Solihin. And now is the session for question answer. Anybody here? Question, comment, or anything else, please? Oh, Mr. Hari? Not it. I check. You would like to answer question? You have question?
Yeah, thank you.
Okay,
Thank you
please.
very much, Dr. Risnanda. Thank you for your presentation, Mr. Aminul. I am curious about the order of the filters that you use. If I'm not mistaken, you compare to filter moving average and Savitsky-Golay. What the value of the order of that filter, and what the consideration you choose the value of the order of the filters? Thank you.
Okay, thank you for Mr. Hari for the questions. For the order for the Savitsky-Golay filter is actually order 2 because we have done the test for the third order and second order. The most suitable is second order because it's not so adaptive. When we try with the third order, the signal is not so smooth because it's to fit with the original signal. When we try with the second order, it can smooth as we desire.
Okay.
Okay.
Thank you very much. Interesting.
The others audience, any question, comment, or anything else, please? You still have 7 minutes to the end of the session. Any question again? Comment? Maybe I have one question for you. In this case, you have the method of SPR, right?
Yes.
Surface plasmon resonance. Sometimes it cannot discriminate between the specific or non-specific interaction with the sensor surface. How do you think about this problem? If you have experience for this method.
Okay. Thank you for the questions. So to discriminate or to distinguish between the specific binding or non-specific binding can be examined from the signal. If the ascending signal is so steep, I mean like step function, not like the exponential functions, it means there is a mass transfer there. So there is happening there not only the binding between the antibodies and antigen, but also there are non-specific binding like van der Waals interactions, cysteine on any hydrogen binding. We can determine it by the signal response, the ascending, and the time duration from the baseline to the signal response samples. And also we can see it from the signal descending from this sample to the baseline. If the signal is goes back to the baseline, it means that there are unspecific binding. If the signal is not back to the original baseline, the specific binding between antigen and antibody is occurring because the binding of antigens and antibody is strong enough, and the flushing with PBS will not releasing the interaction between antigen and antibody.
Yes, I got your good answer for this presentation and my question. Okay, anybody here? Any question, comment, or anything else? Maybe once more again. I check, not yet. But before we ended this session, I remind again, please fill out your attending here in the chat box link URL. And then the second one, before we ended this session, I request to you, please switch on your web camera for taking the photo group of the session. Okay, I request you to open your webcam. I would like to tag your photo group, our photo group. I have 2 pages, so you can freely to tag your freestyle. This is okay. Okay, are you ready? To Mr. Heru Susanto, Mr. Ray Ezra, could you please open your webcam or switch on? Mr. Jalu, Mr. Suryadi, Mr. Iwan Muhammad Erwin, Miss Ayu Sabrina, Miss Pita, Mr. Purwoko Adi, Miss Eka Sari, Mrs. Purnomo, Husnul Khotimah, and so on. All right, I would like to count down the first, wait a moment, count down, 3, 2, 1, smile. Okay, wait a moment for the page 1, for the page 2. I tag again, 3, 2, 1, smile. All right. I think this is the time's almost over, and the last session, I would like to thank for the presenters in this session, and maybe we have next session after lunch break. So for this time, I am Rislandar from Research Center for Informatics, Indonesian Institute of Sciences. Thank you very much for this session, and bye-bye.
Thank you.
Berawal dari cita dan asa untuk membangun negeri, memberikan segenap rasa dan tenaga untuk menghasilkan pemikiran terbaik bagi negeri tercinta, kami ada untuk Indonesia. Mewujudkan diri sebagai Lembaga Ilmu Pengetahuan Indonesia yang andal, profesional, inovatif, dan berintegritas dalam pelayanan untuk mewujudkan visi Presiden dan Wakil Presiden. Indonesia Maju yang berdaulat, mandiri, dan berkepribadian, berlandaskan gotong royong. LIPI memiliki berbagai pusat penelitian tersebar di seluruh Indonesia yang berada di bawah kepala LIPI, Deputi Ilmu Pengetahuan Hayati, Deputi Ilmu Pengetahuan Kebumian, Deputi Ilmu Pengetahuan Teknik, Deputi Ilmu Pengetahuan Sosial dan Kemanusiaan, Deputi Jasa Ilmiah dan SDM Pendukung Iptek di bawah Sekretariat Utama LIPI. LIPI berperan dalam proses penyusunan dan kelahiran berbagai regulasi dan kebijakan pemerintah terkait aspek ekonomi, politik, sosial, dan budaya. Selain itu, LIPI juga mengelola data dan timbangan ilmiah dalam rangka konservasi keanekaragaman hayati. Menerbitkan tanda pengenal unik publikasi ilmiah terbitan berkala, membuat repositori ilmiah skala nasional, dan memiliki kewenangan sebagai pembina Jabatan Fungsional Peneliti Nasional, serta melaksanakan proses pengukuhan profesor riset di Indonesia. Kini, LIPI juga mendukung percepatan penanganan COVID-19, baik melalui riset berupa kajian maupun produk, maupun pengembangan SDM melalui program Indonesia Memanggil. Untuk mendukung riset, LIPI memiliki 5 kebun raya sebagai pusat konservasi flora ex situ. 2 museum yang memiliki koleksi flora, fauna, dan kesejarahan alam Indonesia, Indonesia Culture Collection yang menyimpan koleksi mikroorganisme terbesar di Indonesia, infrastruktur riset strategis, dan beberapa pusat berskala internasional, yaitu Asia Pacific Center for Eco-Hydrology atau APCE. LIPI telah menghasilkan hasil riset yang berkualitas dan bermanfaat bagi masyarakat, meliputi keanekaragaman hayati, lingkungan dan maritim, ketahanan pangan, pertanian, dan peternakan, kesehatan dan farmasi, material maju, energi, teknologi, informasi dan komunikasi, pertahanan dan keamanan, dinamika sosial, kemanusiaan dan kebudayaan, kebencanaan, inovasi teknologi dan pendayagunaan iptek, pelayanan, pengujian dan pembinaan ilmiah, serta peningkatan kualitas SDM iptek. Kerjasama keilmuan LIPI dalam negeri meliputi kerjasama penelitian, lisensi teknologi, pengembangan, aplikasi dan komersialisasi hasil penelitian, kerjasama non-penelitian, dan konsultasi kepakaran LIPI. Sedangkan kerjasama luar negeri, LIPI melakukan joint research, workshop, pertukaran peneliti, dan beasiswa mancanegara, selain aktif menjadi anggota dan focal point di berbagai organisasi internasional. Melalui kolaborasi bersinergi, menghasilkan riset yang berkualitas LIPI terus memberikan manfaat nyata, kontribusi berarti, dan turut mewujudkan cita dan asa membangun negeri kita tercinta, Indonesia.
Jurnal Elektronika dan Telekomunikasi or JET is a journal published by Pusat Penelitian Elektronika dan Telekomunikasi LIPI. JET presents high-quality articles on the latest research and development in the field of electronics, telecommunication, and micro or nanoelectronics engineering. JET provides a platform to share research in the areas such as digital signal and image processing, network theory and circuit design, radar and sonar technology, antenna and wave propagation, wireless and optical communication, microelectronic system, electromagnetic and electronics materials, emerging and advanced fabrication technology, and so on. JET is indexed by internationally renowned indexers such as DOAJ, Google Scholar, Mandiri, and etc. JET is also ranked as Center 2 in Kemendikbud Green Accreditation System. There are 2 JET editions published every year, and all of them are available in open access to support global exchange of knowledge. All submissions in JET are accepted online, and each submission will be blindly reviewed by at least 2 peer reviewers. Most importantly, all submissions are free of charge, and therefore, no article processing fee applies. For more info, please visit www.journalet.com or visit our social media accounts.
Berawal dari cita dan asa untuk membangun negeri, memberikan segenap rasa dan tenaga untuk menghasilkan pemikiran terbaik bagi negeri tercinta, kami ada untuk Indonesia. Mewujudkan diri sebagai Lembaga Ilmu Pengetahuan Indonesia yang andal, profesional, inovatif, dan berintegritas dalam pelayanan untuk mewujudkan visi Presiden dan Wakil Presiden. Indonesia Maju yang berdaulat, mandiri, dan berkepribadian, berlandaskan gotong royong. LIPI memiliki berbagai pusat penelitian tersebar di seluruh Indonesia yang berada di bawah kepala LIPI, Deputi Ilmu Pengetahuan Hayati, Deputi Ilmu Pengetahuan Kebumian, Deputi Ilmu Pengetahuan Teknik, Deputi Ilmu Pengetahuan Sosial dan Kemanusiaan, Deputi Jasa Ilmiah dan SDM Pendukung Iptek di bawah Sekretariat Utama LIPI. LIPI berperan dalam proses penyusunan dan kelahiran berbagai regulasi dan kebijakan pemerintah terkait aspek ekonomi, politik, sosial, dan budaya. Selain itu, LIPI juga mengelola data dan timbangan ilmiah dalam rangka konservasi keanekaragaman hayati. Menerbitkan tanda pengenal unik publikasi ilmiah terbitan berkala, membuat repositori ilmiah skala nasional, dan memiliki kewenangan sebagai pembina Jabatan Fungsional Peneliti Nasional, serta melaksanakan proses pengukuhan profesor riset di Indonesia. Kini, LIPI juga mendukung percepatan
Okay, good afternoon to all the presenters and participants of the 2020 International Conference on Radar, Antenna, Microwave, Electronics, and Telecommunication, Icramet 2020. So we go to the 70th paper session for this conference, and let me introduce myself. My name is Robert Victoria Manurung, and I'm from Indonesian Institute of Sciences, or LIPI. I'm act as a moderator of this session. So before we start, let me give you a brief introduction about this session. This topic area are RF and microwave theory and devices, antenna devices and technique, electronic materials, component and circuit, remote sensing and radar system. In this session, we have 5 presenters. First, Mr. Pisit Pokaratkul from Mahidol University, Thailand. Second one is Ms. Jaisri S. Kulkarni from Viswakarma Institute of Information Technology, India. And then the third one is Mrs. Natalita M. Nursam from Indonesian Institute of Sciences, LIPI, Indonesia. And the fourth, Mr. Iman Haidarpur Sarezei from Korea Polar Research Institute, Palpri, South Korea. And lastly, for the fifth one, the fifth presenter, Mr. Rumadi from National Institute of Aeronautic and Space, Lapan, Indonesia. So, may I know all the presenter is present right now? And I would like to gently remind some matters to help the session run smoothly. So for all the presenter in this session, please keep your video on until the session finish. We will have screen capturing session by the end of the presentation. Also fill out the attendance from during this session. Our co-host will send you the link in the chat room. Please have your presentation file ready in order to answer some questions from your slide. The time for each presenter is 20 minutes long. Please make sure you are present during your question and answer session. For the participant who look like to ask the question, please use the raise hand feature at participation menu on your Zoom. Without further ado, let me start with the first presenter. So for the Master Pisit Pakuratko, the time is yours.
I present the topic milliwave path loss prediction model using gesture theory for urban areas. Alright. Introduction. Game model path loss data. Comparisons of the models and conclusion. Today, there are many models to predict the path loss of the 0.8 to 0.0 gigahertz. In this research, I proposed the path loss model for modern 5G wireless communication using scale model. The choice of path loss model consists of the empirical model, semi-deterministic model, and deterministic model. The objectives of this research: one, to model path loss with precision theory, to propose an empirical path loss model for real environment in complex urban area with an accuracy. In the next topic, gate system theory. Gate system theory was initiated in 1982 by Deng Zhulong. A gate system is defined as a system containing uncertain information presented by k number and k variable as shown in figure 1. In figure 1, show the concept of a gate system. In the k model consists of the known information k number and unknown information. If we feed the input k variable into the game model, so the game model compute the output k variables. This slide shows the game model. We build the game model from the input k variable. If we feed the k input variable into the game model, so the game model compute the output play model. Next, GM1 model. Let x0 be a raw series and x is the accumulated generating operation x0 as shown in the equation 1. We call the equation is a predifferential model. This model is called GM11 model. It is consists of one variable as shown in the equation 2, where A is the development coefficient and B is the input. Since x0 and x1 satisfy the GM11 model as the following equation in the equation 3, we can compute the error from the yn minus b a hat and compute the minimum cost function, where b is called a data matrix and yn is the data vector. Next, solution of the GM11 model are according to the risk square method. So we have the A hat as in the equation 4, and the another solution of A and B also in equation 5. In the next, we use the widened equation. The widened differential equation as shown in the equation 6. We set the initial value x01 as shown in the equation 7. The complete solution as shown in the equation 8. Let t equal k plus 1. So we have the x has 1 k plus 1 as shown in the equation 9. The predicted value x has 0 k plus 1 as shown in the equation 10. From the principle of K model, so we set the modeling process as the x at 0 from the inward accumulated generating operation so-called GM11, so-called accumulated generating operation so-called x0 as in equation 11. Take accumulated generating over into the original sequence x0. Construct the data matrix E and the data vector Y and identify the development coefficient A and the gray input B by the inverse of the B times post times B times the B transpose times the Yn. So we have the forecast the original sequence x0 as shown in the equation 12. Now from the model process, we conclude as in the flowchart in the right side of this slide. The building method from the measured data. It is captured the plot data at the frequency of 28 cycles. From the graph divided into groups in the cross point, show the measured data for the bright oxides, and the other group show the non-light oxides. The rectangle point represent the measure hard load of the 28 cycles, and the circle point represent the measured data for the soft load at 28 cycles. From the data, we divided the data into groups, training data and the testing data. We build the K model from the training data. In the figure 3, show the K model path source from the training data. In this graph, we can see the green line represents the measured data for the right side. The red line represents the K model, and the blue line represents the linear regression model. From this graph, we can see the red line represents the K model, give the accuracy more than linear regression for the right side frequency of the 28 cycles. In the next figure, we build the K model for the non-light oxide for the soft load at the 28 cycles. From the graph, the green line represents the data the measurement data. And the red line represents the gray model and the blue line represents the linear regression model. From the graph, we can see the gray model gives the accuracy more than the linear regression. In the RAS model, we build the gray model for the outside of hard rules. The key line represents the measured data. The red line represents the gray model, and the blue line represents the linear regression. From the graph, we can see the gray model provide accuracy more than the linear regression in the left-side hard rule. In the next step, we test the accuracy using the testing data for compute the minimum MAE comparing with the empirical model. In this case, the password model was trained with the mentioned password data at the frequency of the 20 seekers. And to compare the proposed model with the 4, 5G empirical models, both CI and FI types, namely 5GCM, 3GBP matrix, and MM matrix. From the experiment, the proposed gray model, right upside, and null upside model provide the prediction with the minimum MAE comparing with the empirical models. Okay, I finished my presentation. Thank you for your attention. Have you any question?
So thank you very much, Mr. Pisit, for the interesting presentation. Before we start with the question and answer, especially for Mr. Pisit, could you fill out the attendance list, and then you can find the link on the chat box, please. Okay. Now I invite the audience to raise the question, comment, or suggestion regarding the presentation.
Okay, good afternoon. The equation, we build the gray model from the training data using the gray model method, or we call GM1. After we build the gray model, we compare the linear regression model. Okay. Right?
Okay. Okay, thank you. So any other question from the floor? So if not, may I ask one question to you, Mr. Pisit? So as in your conclusion, you said that the proposed gray LOS and NLOS models is provide as very minimum, what we say, prediction, right? Error for prediction. So could you tell me what the biggest challenge that can enhance the performance of the prediction itself?
Okay. After build the gray model, we compare the testing data from the measurement live side and non-live side using the mean absolute error, in the we have this formula in the paper. You can see in the paper. Okay.
Okay. I still give a chance for any presenter or maybe a participant want to raise a question to Mr. Visip. Okay, if not, then we end the session for Mr. Visip presentation. So give a big applause for his presentation for today. So now we go to the next presenter for Miss Jaisri Kulkarni from Visvakarma Institute of Information Technology. The time is yours.
Hello everyone, greetings of the day. Myself, Dr. Jaishree Kulkarni, would like to say thank to Icramet 2020 team for giving us an opportunity for presenting our research work on low profile, multiband and wideband C-shaped monopole antenna for 5G and wireless LAN applications. My co-author is Choyan Desmond Sims from Fengchia University, Taiwan. The content of our presentation are objective, proposed antenna structure, operating mechanism, followed by parametric study, results and discussion, and finally conclusion. Objective of our research work is to design and develop low profile, multiband and wideband monopole antenna for 5G and wireless LAN applications. So in order to design wideband and multiband antenna, first I would like to give the brief antenna structure and design methodology as follows. The proposed antenna as seen in figure 1 consists of two C-shaped radiators as you can see in figure along with microstrip feed line. These two shaped radiators are loaded with small circular radiator of having radius r, and one more radiator is loaded with tuning stub, and backside of proposed antenna is consist of step sized ground. The complete structure is printed on FR4 substrate of 0.8 mm thick, and it is fed by SMA connector as we can see in figure 1. The complete dimensions of proposed antenna are mentioned in table 1 as we can see. The footprint of designed antenna is just only 20 mm into 20 mm into 15 mm. The proposed antenna induces two resonance at 3.9 gigahertz and 6.6 gigahertz. These two resonances will result in 76% of impedance bandwidth in the frequency range of 3.3 to 7.35 gigahertz. So in order to put more insight how the proposed antenna induces such a wide band, I would like to give the brief idea about the operating mechanism of proposed antenna. Here in a first step, or it is the structure antenna 1, here we can see only C-shaped radiator along with step-sized ground as you can see in figure B has been loaded on FR4 substrate of size 20 mm into the 15 mm. The corresponding reflection coefficient characteristics are shown in figure 3. Here antenna 1 is able to generate the resonance around 3.9 gigahertz. Here we can see in figure 1, which is denoted by blue line. This antenna is able to generate the bandwidth of 3.5 to 4.1 gigahertz. In order to induce another resonance around 6.6 gigahertz, here antenna 2 structure is designed in such way that another C-shaped radiator without disturbing the antenna 1 has been loaded on the right side of FR4 substrate. Now, this complete structure is denoted as a antenna 2. Here, antenna 2 is able to generate another resonance at 6.6 gigahertz, which is shown with black line, without disturbing the resonance generated at 3.9 gigahertz. This antenna 2 generate the impedance bandwidth in the frequency range of 6.0 to 6.8 gigahertz. Here from figure 3, it is also visualized that this antenna 2 is not only generates the resonance at 6.6 gigahertz, but it also enhances the bandwidth in a lower band in the range of 3.5 to 4.8 gigahertz. But again, this antenna 2 is not able to cover complete fifth generation new radio and wireless LAN band. So in order to have that, another tuning stub, here we can see at the right side of C-shaped radiator has been loaded without disturbing the compactness feeding position of proposed antenna. Now this complete structure is denoted as antenna 3, and this structure is able to generate wide frequency band in the range of 3.3 to 7.35 gigahertz with 6 dB impedance bandwidth of 76%. So now this antenna is termed as proposed antenna. So here this antenna, as it generates the impedance bandwidth of 76% in the frequency range of 3.30 gigahertz to 7.35 gigahertz, here it confirms that the proposed antenna is in compact in size and it is able to operate in all 5G new radio bands as well as wireless LAN bands. Here, as we have seen, the proposed antenna is in compact in nature, so its mirror performance is very sensitive to the geometric parameters. So parametric investigation is also carried out throughout the operating bands. So the parameters for the parametric studied are selected as the length of tuning stub, here LS we can see in figure shown here. Second parameters, length and width, that is xg and yg of step size ground. Here in first investigation of parametric, that is length of tuning stub, here we can see that as length increases from 2 mm up to the 5 mm in the step increment of 1 mm, here as length increases from 2 mm up to the 3 mm, we can see that from figure, this increment in length of tuning stub help us to achieve the impedance bandwidth. At LS equal to 3 mm, we can see that the bandwidth impedance matching has been achieved and desired bands are also achieved. But as we go on beyond 3 mm, we can see that there is a disturbing of impedance matching. Both resonances are disturbing. So here to maintain desired bands, tuning stub length 3 mm is optimized using CST Microwave Studio software. Then in order to again see the effect of xg and yg, which is the length and width of step size ground on the impedance bandwidth of proposed antenna, in figure 5, we can see that as xg increased from 3 mm in the step increment of 3 mm, we can see that this increment in the length help us to achieve the impedance bandwidth. And here at 9 mm, we can see that again our desired bands are restored with achieved impedance bandwidth. Here as we go beyond 9 mm, for example, xg is equals to 12 mm, we can see that which is denoted by black line, the impedance matching deteriorated and our desired bands got disturbed. So XG 9 mm has been optimized using CST MWS. Now again, in order to check the width of step size ground on the impedance bandwidth of proposed antenna, here width has been increased from 0 mm in the step increment of 1 mm. So here from figure 6, again we can see that increment in width of step size ground help us to achieve the impedance matching at desired resonances with achieved impedance matching. So YG is equals to 2 mm has been optimized in order to restore the desired bands. Here we can also see as YG increased beyond 2 mm, for example YG is equals to 3 mm, impedance matching has got deteriorated, especially in lower band. So YG equal to 2 mm has been optimized in order to restore the achieved band. So this is about parametric investigation. Now, in order to see whether the proposed antenna has good scattering performance as well as radiation performance, here the few slides will give the more light on simulated results and discussion about the proposed antenna. Here we can see first scattering result, that is reflection coefficient characteristics of proposed antenna. As I told previously, proposed antenna consists of two shaped radiator along with tuning stub, and it is fed by SMA connector. So here from figure 7, it is easily visualized that the proposed antenna exhibit impedance bandwidth of 76% in the frequency range of 3.30 gigahertz to 7.35 gigahertz, which confirms that the proposed antenna cover the 5G new radio N77, N78, N79 and wireless LAN bands. So this validates that the proposed antenna has achieved good impedance matching and it's suitable for 5G NR and wireless LAN applications. In order to validate the radiation performance, including radiation patterns, gain and efficiency, the proposed antenna exhibit here a two-dimensional polar radiation pattern of proposed antenna. Here in figure we see that blue line indicates that cross-polar and red line indicates here copolar. Here we can see that the magnitude of copolar in E plane as well as H plane are less than magnitude of cross polar is less than magnitude of copolar at both resonances 3.9 gigahertz as well as 6.6 gigahertz. Also we can see that the cross polar are in the shape of approximately 8 shape in a E plane. It indicates that the proposed antenna has omnidirectional radiation characteristics which will ensure good signal of quality while implementing in wireless devices. Again, in order to check the gain and copolar radiation pattern, here figure 9 presents three-dimensional simulated radiation patterns of proposed antenna. From figure 9, it is visualized that the proposed antenna exhibit the gain around 2 dBi at both resonances 3.9 gigahertz and 6.6 gigahertz. Here figure 10 also exhibit the gain and efficiency of proposed antenna. From figure 10 we can say that the proposed antenna exhibit gain around 2 dBi as well as efficiency around 85% in the operating band, which indicates that the proposed antenna is also good candidate for wireless communication. So based on above design structure, working mechanism and simulation result, we can conclude that an innovative low profile and simple structure antenna was designed which depicts 6 dB impedance bandwidth of 76% in the frequency range of 3.3 GHz to 7.35 GHz. Therefore, the proposed antenna fulfills the required bandwidth of 5G NR, N77, N78, N79 and wireless LAN bands for wireless applications. The proposed antenna has a very small design footprint of 0.26 lambda into 0.19 lambda, which is around 20 mm into 15 mm. This lambda represents free space wavelength calculated at 3.9 GHz. And also the proposed antenna has a thickness of 0.8 mm only. The proposed antenna also satisfies the required radiation performance of multi and wideband operations, conforming good quality of signal strength for wireless applications. Hence, the proposed antenna has a very low profile, simple and innovative structure, and it is also economical and good radiation performance. It is an excellent candidate for next generation wireless devices. So I have referred following references to design C-shaped monopole antenna. These are the references. Thank you all of you for patiently listening my presentation. Thank you so much.
Thank you very much, Ms. Jayasri, for the very interesting presentation. So now it's time for me to invite the audience to again address the question or comment or suggestion regarding the Ms. Jayasri presentation. Does anyone want to ask some question? Okay, we're still waiting for the floor to give some other question.
I have a question, sir.
Yeah, sure. Oh, sorry, maybe Mr. Ken Paramudia.
Okay, thank you. So, from what I know, we normally use 10 dB impedance bandwidth to know the working frequency of our antenna, while you were using a 6 dB impedance bandwidth in your design. Is there any particular reason why using the 6 dB impedance bandwidth? Because as far as I know, a 6 dB impedance bandwidth will give you just 75% of radiation power. Thank you.
Thank you very much, sir, for your nice question. Sir, whatever survey I have done, I have come to know that whatever next generation devices are planning to shift at 6 dB reference. Many antennas I have seen which are designed for antennas for smartphone application. They are also designed for 6 dB. So, sir, in order to suit for next generation wireless devices, I have considered as a 6 dB.
Okay, thank you.
Thank you. Yeah, thank you, sir. Thank you.
Any other question? So, Ms. Jasri, maybe I want to ask you a question. So, it's a very good presentation and result due to the simulated for your C-shaped monopole antenna. So, I just want to know what we need to consider if your antenna design will be implemented into the real antenna and apply for the 5G, as you mentioned in your presentation. And also, I'm curious for your say in the last slide in the conclusion that it is a good economical. Would you tell us more about this?
Yes, sir. Sir, thank you for your question. So I would like to go for first your second last question. As I have written, it is economical. So whatever literature I have done, sir, I have found that the existing antennas are printed on expensive Rogers substrate, sir. That is RTDuride Rogers substrate, which is a very expensive and also costly. So my antenna is printed on FR4 substrate, sir, which is also easily available and economical, sir. So here I have written that sentence. Ki my antenna is economical, and sir, around fabrication cost will be just 700 Indian rupees, sir. Maximum 700 rupees. So, sir, it is written antenna is economical, C-shaped monopole antenna.
Okay, thank you for your answer. So, any other question? Oh, Mr. Ignatius, would you address the question to Ms. Jaisri?
Okay, thanks for the time, sir. Now I would like to ask the question related to technical aspect about the antenna for 5G. The first question is, what is the advantages of your antenna instead of directional antenna? As we know together that 5G and in cellular communication sometimes use the trisectoral, that each antenna is very directional to each sector. Then what is the advantages of your antenna? That if I got that your antenna is monopole, so the direction is omnidirectional. So the second question is, what is the suitable 5G application for your antenna? Considering that the 5G architecture is sometimes use OFDM. That's my question. Thank you.
Thank you, sir. For first question, I would like to answer, or I would like to suggest you to go for MIMO antenna, sir. Multiple input, multiple output. So as you have seen, my antenna is a monopole antenna and it has omnidirectional radiation characteristics. So in order to have that directional, or in order to avoid that interference in existing bands, here I can go with MIMO technologies, that is multiple input, multiple output technology. Yeah, and sir, will you please repeat second question, please, sir?
Yeah, my question is related to the MIMO antenna, because as far as I know that 5G architecture should be include the OFDM or OFDMA for their multiple access. So if we implement the 5G using the omnidirectional antenna based on your antenna design, what is the suitable 5G application using omnidirectional antenna? That's my question for second question.
Sir, for sub-6 gigahertz, we do not require directional antennas, sir. Omnidirectional antennas will work, which lie in frequency region 1. And if we see the frequency region 2, which is above 6 gigahertz, like 28 gigahertz, 60 gigahertz, which will come under millimeter wave applications. So in that case, we need those directional antennas, sir.
Okay, thanks for your answer.
Okay.
Yeah, okay. I hope, sir, you satisfied with my answer. I hope so.
Yes.
Yeah.
Yeah.
Thank you so much.
Okay. Once again, thank you very much, Ms. Jaisri, for the presentation. So please give an applause for her. And now, because his time is very limited, now we go for the next presenter, Ms. Natalita M. Nursam from Indonesian Institute of Sciences. The time is yours.
Good afternoon, Icramet audience. Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to thank the organizing committee of Icramet 2020 for providing today's opportunity. My name is Natalita, and I'm from the Research Center for Electronics and Telecommunication of the Indonesian Institute of Sciences, or LIPI. And I'm here today to present our work on the upscaling of monolithic dye-sensitized solar module. Solar energy is one of the most available and accessible renewable energy sources with enormous potential. To put into perspective, If we install solar panel with only 8% of efficiency in the areas marked by the black dots here, they can actually produce 18 terawatts of energy, which is a lot more than the energy produced by coal, wind energy, biomass, etc., all combined. And for those who may not be familiar with the development of photovoltaic over the years, there are 3 generations of solar cell technology. The first generation is the silicon and wafer-based solar cells, which have been dominating the market today. It is then developed into second generation, which is based on thin film and chalcogenide materials. And the most recent technology is the hybrid solar cells, which includes dye-sensitized solar cells, or DSSC. DSSC is typically composed of 2 electrodes. We call them photoanode and counter-electrode. The photoanode is made from a layer of semiconductor covered with dye molecules that absorb photon energy from the sunlight and produce electrons. That's why we call this type of solar cell as dye-sensitized. The photo-generated electron then flows to the external load, producing electricity and then regenerated back to the initial state of dye. The DSSC has a number of attractive features, particularly compared to the traditional silicon-based solar cells. It is much cheaper because of the material used to build the cell, and it can be made in a typical laboratory environment without any specific requirements. It is also attractive, can be made flexible, colorful, or transparent. And since it is cheaper, the return of investment for DSSC is much shorter than silicon. And then it also works better under low light, so it can be used in indoors, unlike the silicon solar panel that has to be installed in our rooftop. So the competitiveness of a solar cell is basically measured by 3 factors that we call the golden triangle. This golden triangle is essential to capture the market share. One of the golden triangle is cost. And when we look back at DSSC and break down the structure, we can see here that a DSSC typically has 2 pieces of transparent conducting substrates, which is shown by the teal colored squares here. A study that estimated the manufacturing cost for hybrid solar cells, including DSSC, shows that the conductive glass substrate in DSSC actually constitutes 36 to 64% of the total material cost. So this is a huge number, and it actually contributes to the highest cost that dominates the material cost of DSSC. As shown here, this is a typical structure of a traditional DSSC that we call sandwich. You can see that there are 2 FTL glasses used in this structure. To solve the material cost issue, as I mentioned before, what we want is to reduce the number of FTL glass. This innovation here is called monolithic DSSC, where both anode and cathode are located within one conductive substrate instead of 2. Unlike sandwich, the monolithic DSSC requires an additional material in the form of zirconia or other wide bandgap material to separate the electrodes. So while the concept of monolithic DSSC is economically appealing, most of the current research, however, have been dominated by materials development, and less work has been devoted to engineer and effective design for monolithic solar modules. So the work that I will be presenting here aims to scale up the monolithic DSSC into module and see how it will affect the photovoltaic performance. Before we continue, we need to see the concept of upscaling. So upscaling is basically done to increase the output of solar cell. There are 2 ways to get higher power output. First is by enlarging the active area of DSSC. This method, however, produces high series resistance, which is undesirable in solar cell. The second method is by making interconnection from small cells. There are two ways: through external connection, which is basically ineffective, and through internal connection, which is what we are doing in this work. And this is not an easy option because the cells need to be connected electrically, yet separated chemically. The fabrication of monolithic DSSC is started with design and preparation. This is the design of our monolithic cells, and in this step, we remove some part of the FTL glass by scribing the conductive film to separate the electrodes. Then all layers are screen printed in the following order. First, titania, followed by zirconia, and then carbon. This step is then followed by dye immersion to sensitize the titania. And then finally, the fabrication is ended with electrolyte injection and encapsulation with a non-conductive glass. Meanwhile, for the module, the fabrication is pretty much identical with the same layers of materials by scribing the FTL glass first, and then followed by deposition of titania, zirconia, and carbon. As an upscaling demonstration, here we made a module containing 3 cells with grid-type pattern that was interconnected in series. First, we will analyze the microstructure of the layers. SEM images were taken to inspect morphology within the interfaces of titania, zirconia, and carbon layer. Here it shows that each layer has been formed separately with no mixed up materials across different layers, which is also confirmed by the elemental mapping images shown here on the right side. High resolution SEM also shows that each layer has different morphology, even though all of them are basically consist of particles, wherein titania has the smallest size of particles, which is less than 100 nanometer. So the electrical performance of the solar cell was studied by measuring the current voltage or IV curve, following a standard diode measurement. And from there, we can determine the power conversion efficiency as well as other parameters such as fill factor, open circuit voltage, and short circuit current. All of the measurement was conducted under irradiation from a solar simulator with a standard AM 1.5 filter. And before proceeding to module, it is first necessary to understand the difference in the electrical properties between monolithic and conventional sandwich cell. So here, we compare 2 cells with identical materials but with different structure. We can see that the sandwich cell basically shows better solar cell characteristics from the shape of the IV curve, which is mostly due to higher fill factor value. The lower performance produced by the monolithic DSSC here is quite understandable because the monolithic DSSC has multiple solid layers across the cell, and particularly the use of zirconia as spacer has likely to contribute to higher parasitic resistance. And after being scaled up to module, there are 2 ways to analyze. First, we will see the effect of enlarging the cell size from small cell with an active area of 0.25 square centimeter to grid-shaped cell with an active area of 3.44 square centimeter. There is a significant increase in the short circuit current, which is well expected due to the increase in light absorbing area. And next, when the grid cells were connected to a module with a total active area of 10.32 square centimeter, we can see here that the module produced an open circuit voltage of approximately 1.7 volt, which is the summation from 3 cells, as we are using series interconnection. Other parameters remain unchanged, And these results suggest that the interconnection within the module has functioned properly. So in conclusion, we have demonstrated the upscaling of monolithic DSSC into module. And even though the monolithic DSSC is still lacking performance compared to the sandwich DSSC, it can be further improved by focusing on reducing the parasitic resistance in the future. The interconnection of monolithic DSSC was shown to be successful, and overall, it shows a promising concept for a solar panel that has low material cost and easy to fabricate. This research was funded by Insinas Kemenristek Dikti and LIPI, and for more information, you may check out our group website here. Thank you very much for your attention, and I'm happy to answer any questions or to have further discussion if requested. Thank you.
Thank you very much for Mrs. Natalita for the interesting presentation. So I invite the audience to raise a question due to Mrs. Natalita presentation. You can use the feature for the raise hand on your Zoom.
Sorry, can you repeat the question? Sorry, I was disconnected before.
Oh, not yet address any question to you, Mrs. Natalita. Just ask the audience. Okay.
Okay.
Maybe I want to ask a question then to you. So in the conclusion, you said that monolithic DSST is a lower performance compared than the sandwich type. So you can elaborate more how to prevail this problem. Is it possible that maybe much higher compared than the sandwich? How about your comments?
Okay, thank you for the question, Mr. Moderator, Pak Robert. So yes, in conclusion, actually the monolithic solar cell here, it has shown lower performance compared to the sandwich, but of course, in terms of the cost, the manufacturing cost and the material cost, it will be much better because it is lower. In terms of the performance, actually from our result, we can analyze that the lower performance is primarily caused by the parasitic resistance because we know this problem. So in the future, we can address it by for instance, increasing the conductivity of the counter electrode, for example, by using maybe thicker carbon layer, or maybe optimizing the spacer layer like the zirconia layer. That's my answer. Thank you.
Thank you. Still any other question from the floor? It is not. So thank you, Ms. Natalita, for the interesting presentations, and please give applause for her. And now we go to the next presenter, Mr. Iman Haidapur Zarizi from Kopri, South Korea. So Mr. Iman, time is yours.
Hello, my name is Iman and my family name is Haidarpur. On behalf of Korea Polar Research Institute at the Center of Remote Sensing and Geospatial Information System in cooperation with Korea Aerospace Research Institute in the section of satellite operation and application. We are pleased to present this presentation with the title of Ultra High Resolution COMSAT 5 SARS CIS Random Radiometric Anomaly Formulation based on hybrid domain texture decomposition. We would like to first categorize the presentation into 6 different sections. First of all, we would like to talk about introduction, then we are going to talk about random radiometric anomaly. Hereafter, we would call it as RRA. In third, we will talk about the resolutional profile of RRA. And in the fourth section, we are going to analyze the RRA presence based on time frequency investigation. And in the fifth section, we are going to investigate the spectral behavior between the image, and then we would have the results in the last section. As you know, synthetic aperture radar is an active current microwave imaging sensors which are sending some kind of current pulses, and then they're going to receive these pulses and processing them and then shaping the image. The concept of the texture is referred to the train which are being backscattered as a function of radar spatial resolution. The backscatter signals are mapped into a complex matrix under different elimination scenarios, and they might contain any combination of systems modes. However, we are talking mainly about the raw data. In this specific concepts, when we are considering a spatial resolution, accordingly, SAR image present distinguished features of the texture, which are mainly associated with backscattering interactions of the train. The sensor is experiencing geometric distortions, trajectory displacements, and atmospheric deviations, and other sources of the errors, which are very important for backscatterings. Hence, a superposition of these non-coherent independent reflections within a spatial resolution cell will happen. These kind of anomalies or defects or non-coherency in the raw data are called random radiometric anomaly, which has a gamma distribution. And also, RRA, it doesn't have any specific pattern. When we are talking about random radiometric anomaly, mainly we are talking about the backscattering coefficient of the train. And when we are talking about the backscattering coefficient, we are talking about sigma or sigma naught. Technically, RRA or random radiometric anomaly that we talked in the previous slide, that it has several sources of errors, are going to be presented in the backscattering coefficients in the shape of a multiplicative noise that we modeled it here as NAT. NAT is the random radiometric anomaly. As you can find it out, it has an index of T, which shows that it is quite time dependent. The same as other noises that you can find in every aspect of our life. RRA, it also has some kind of distribution function. According to the analysis, here we assign a symmetrical probability distribution function which follows a gamma distributions, and we assigned it to RRA. For the purpose of analysis of RRA here, we use a COMSAT-5 SAR satellite, which were mainly deals with SAR sea ice. As you can see here, this is the reference image of the COMSAT-5, and accordingly, we extracted a Curtis's image of the reference image. Here you can find the minimum level of the RRA, and you can find the maximum level of RRA. As you can find, the floating ices, it doesn't have that much of the RRA, but as you go toward the ice or open water, you can find high level of RRA. You can find that how random radiometric anomaly is going to change the pixels of the image. As you can find in several cases, RRA is going to affect the profile of the image in both azimuth and range directions. Here we provided two scenarios of the image profiles under the severe RRA presence and under the suppressed RRA position. As you can find, the presence of RRA is very important to the image quality. As we talked in the previous slides, RRA is mainly dealing with sigma naught or coefficient backscatters. Hence, we need to extract the coefficient backscatters of the sand, and accordingly, when we are talking about backscattering, we are talking about the raw data. This algorithm that we propose here is kind of algorithm which is based on COMSAT 5. We inserted the image into this algorithm, and after several processing, the raw data will be generated. It is kind of time frequency algorithm, and this from step A to the end, every processing steps would be working to generate the raw data. These are the parameters functions that we use in order to generate the raw data. As you can find here, this is an overlay image of the RRA based on the backscattering, which has been overlaid on the reference image. As previously we showed, the presence of RRA is highly concentrated in upper water areas or in ice flows edges, but not in the thick ices. You can see this is the backscattering profile or resolutional profile of the COMSAT 5, that how the RRA is affecting the profile in both range and azimuth directions. The same as the image, that RRA is affecting the resolution of the image, RRA is also affecting the raw data. And we need to extract its specifications. Accordingly, we use a time frequency decomposition scenario based on wavelet transform. As we talked before, we assigned a gamma distribution, which is asymmetrical probability distribution functions, to the RRA. As you can see, the image at every scale is going to be decomposed. Every decomposition has its own probability distribution functions, and these are the equations that we are using in order to extract the profile and specification of RRA. As the decomposition continues, it is quite obvious that the RRA suppression is working, and as the decomposition continues, the level of the signal will be improved. Here we have two presentations of the RRA suppressions. On the left hand, we are seeing the image resolution, and on the right hand, we are seeing the backscattered resolution. As you can see, at every step of the decomposition, the level of the signal is improved and amplified. You can see that, for example, in the third decomposition scenario, the backscattered signal is quite better than the second, and also the second is better than the first decomposition, and it is the same for the reference image. You can see also here that decomposition on the image is also working properly. But as we talked, this is the decomposition scenario and the profile of the RRA, but we need to understand how RRA is affecting the Zygmunt node. Accordingly, we modeled two adjacent resolution cells in an observation based on this. This is the first resolution cell, and this is the second resolution. The first resolution cell, it has its own RRA, and the second resolution has its own RRA according to the probability distribution function, which is gamma. We extracted their probability distribution function and also the property between these two right after the calculation of the spectral investigation of RRA. Finally, we found something like this, which is the spectral properties of the RRA. According to the decomposition scenario that we earlier mentioned, in the decomposition scenario, we are extracting the behavior of the RRA spectral behavior at every step of decomposition. Here you can find several simulations. The first one is the low frequency, which is the main entity of the sea ice texture. To make it short, this is the major entity of the texture, which is not going to be affected by RRA, or we can talk that this peak here in the low frequency part is due to the presence of thick ice flows. You can see that as the decomposition continues, they are going to be amplified, the low frequency part, but their difference value is not that much. But when we are talking about the high frequency part, which are mainly ocean, open waters, or sea ice ages, you can find that there are several types of RRA in the open waters and ice flows. We extracted their profile according to the implementation of wavelet. As you can see, as the decomposition continues, the high frequency parts are shifting toward the low frequency parts. This is the first decomposition, this is the second decomposition, and this is the third decomposition. You can see that the third decomposition is quite close to the major entity in the low frequency part. I mean that in the third decomposition, the behavior of RRA is quite similar to the major entity of the texture. Hence, we think that if you are going to amplify or suppress the RRA, it's better to focus on first and second scale. To make it short, in this presentation slide, we talked about the RRA, specifically in COMSAT-5, and while we are dealing with SARS sea ice, we extracted their behaviors on both image and sigma naught based on wavelet decomposition. According to the wavelet decomposition and time frequency formulation, we extracted their spectral behavior. Finally, we found it that if you're going to have some kind of wavelet applications on the texture, it's better to analyze it based on its specific properties. According to COMSAT-5 and sea ice, if you're going to have 3 levels of decomposition, it's better to not go further than the second decomposition. And in the third decomposition, the specification would be the same as the main texture, which is not proper. Thank you very much, and thank you.
Okay, thank you, Mr. Iman, for the nice presentation. So I invite again the audience to raise a question, comment, or suggestion regarding Mr. Iman's presentation. Okay, if not, I just want a little one question to you, Mr. Iman. In your slide, you said you see here that the RRA based on DWT decomposition, the result for the major entity with the result for your proposed in there is very similar. Mm-hmm. So how much similar in percentage for the source data and for your result?
Well, what I wanted to mention that is that, for example, using wavelet and time frequency domain is a proper way for the noise suppression. But according to the result and the spectral behavior, we cannot use wavelet decomposition as much as we want. This is the result of this specification. I mean, for example, the major entity of the texture is located in the low frequency part. And for example, suppose you want to suppress the noise, you're in first stage, you're using wavelet, again, you're using wavelet, and again, you're using wavelet. As much as you're going to use wavelet, you're going to get closer to remove the specific and major entity of the texture, which is not very good. So once the question is this, how much can I use the wavelet decomposition? This is the analysis that, for example, the first scale is quite very good. The second scale is something like good. But in the third scale, if you're going to remove the noise, maybe you're going to remove the major entity of the pixel, which is not recommended.
Okay, thank you for your answer. Is there any other question? So if not, then we'll give applause for Mr. Iman for his presentation.
Thank you.
Thank you, Mr. Iman, for your presentation today. And now we go to the last presenter, Mr. Rumadi from National Institute of Aeronautics and Space, Lapan, Indonesia. So, Mr. Rumadi, time is yours.
Bismillahirrahmanirrahim. Previously, my name is Somadi from Lepanbiak. Thank you for opportunity given. I will present our research with title Quantification of Physical Blockades based on Digital Surface Model Dataset. And from this presentation, there are several outlines: the first introduction, material and method, result and discussion, conclusion, and last acknowledgement. For now, satellite technology play a role important for human life, like the supports navigation, communications, defense, and remote sensing. Satellite communication have two segments: the first space segment, the second ground segment, satellite ground station. All of segments important, either space or ground segments. Space segment is satellite orbiting in space, and ground segment is ground station and all equipment it's supporting. The ground station is key for telemetry tracking and command. Function of TTC or telemetry tracking and command is make sure the satellite perform correctly by provide a connection between the satellite and ground station. And one aspect that must be considered in choose a ground station location is elevation blockage. Why elevation blockades? Elevation blockades have impact. The first block incoming signal satellite, then first acquisition of signal, or as time to be delayed. If the blockage area is located on loss of signal site, an established communication link will end sooner than expected. In essence, the existence of the blockage will result in communication duration being cut off. So, how to determine the location of the ground station that has low elevation blockage? We have digital surface model. DSM is one of elevation model that include buildings, treetops, ground, and everything. The variable obtained from DSM dataset can be used to calculate elevation blockage. Some implementation of DSM device for mapping forest biomass, building detection, building reconstruction, etc. And in material, we got digital surface model of region Biak Island. This data provided by advanced land or observing satellite alloys, and this region of Biak Island and site it is detailed location of Biak ground station, altitude, latitude, and longitude. It is illustration of elevation blockage. Alpha and beta represent latitude and longitude, and the x distance between ground station and blockage, physical blockage, and h is height of elevation blockage. Height x blockage. Equation 1 to calculate blockage angle. Equation 2 to calculate the average amount blockage. Result from equation 1 we can verify by use equation 3 with calculate accuracy to compare data satellite from 8 satellite. Based on figure of profile of maximum elevation blockage on a selected ground station. Based on this figure, the blockage is in the range between 345 to 50 degree. So, based on this result, it can be seen that a communication link to certain satellite which located at 45 azimuth can only be made after elevation reaches 7 degrees. In addition, because there are no blockage in 130 to 270, the ground station can communicate with satellite directly. And then this result we compare housekeeping file to analyze accuracy of estimated blockage. We compare this blockage to elevation of common satellite 8 satellite. The common 0 represent as failed command and common 1 represent success command. From this result, we found that accuracy is 93%. So, according to this result, the proposed calculation is capable of resulting in a representative blockage as accuracy satisfying. Then we propose calculation can be considered to be used in generating elevation blockage map. And it is cycle blockage map and its utilization. Based on this figure, the blockage ranks this figure average elevation blockage map according the generating northwestern region of Biak Island relatively has highest level blockage compared to other regions. And on the contrary, eastern parts of this island seem to be a great place for performing a satellite communication with blockage ranging only from 0 to 2 degrees. Based on this result, it is recommended to place the antenna with current configuration at the RSF small amount of blockage such as western, eastern, and some are located at mountain of Biak Island. To specially analyze the impact to existence of elevation blockage on the link, establish performance for satellite orbiting different orbit. We provide summarize for equatorial and polar orbiting satellite. This is path from orbit equatorial and polar orbit. And the last result, we compare equatorial orbiting satellite and polar orbiting satellite. Based on this figure, it can be seen north region of Biak Island in which is ranging from minus 0.5 to -1 are found not suitable to build ground station because in this area hedge blockage. And for average elevation blockage map for polar orbiting satellite in Biak Island, see that we found the blockage in this region until 10-degree elevation blockage. But other region, the blockage is found very less with a value distribution from 0 to 2 degree. And then we got conclusion in this research. We have proposed a method for quantifying the amount of physical blockage surrounding a ground station. Based on simulation, the accuracy of proposed method reaches up 93%. And this method, it can be used to reference to build suitable location ground station. And we also found all region of Biak Island except northwestern region are suitable for ground station. And the proposed method can be used to quantify the amount of physical blockage surrounding an existing ground station, in which is very useful for operator satellite to send desired command at appropriate time. Thank you for your attention. Thank you for LAPAN to support this research. Thank you very much.
Okay, thank you very much for Mr. Rumadi for the presentation. Is it any question or comment from the floor regarding was Mr. Rumadi presentation?
Any question?
So if not, I want to ask one question to Mr. Wadi. So in this study, you're using a Biak island, right, for the reference data, and then the result is look like it's more flattened, right? It's not the contour or it's not vary. Have you tried to another region in Indonesia with many mountain and there's a valley with a more vary compared than Biak Island? And what do you think about your proposed study?
I'm not yet to try other region, but this research I'm sure because I'm using DSM, digital surface model, that is represent the all of the top in the land. So if we try in region like Jakarta or the region that has building tall, this method so still propose using DSM.
Okay, thank you, Mr. Wadi. So any other question? So if not, then we come to the end of the Mr. Romedi presentation. Can we give applause for him for the presentation?
Thank you.
Now we have finished for the Q&A session. So I will ask all the presenter to switch on your video. So we get we need to for photo session right now. So could you prepare by switch on the video? Okay, for the page one, get ready in count and 3, 2, 1, say cheese. Okay, on the page two, in count 3, 2, 1. And for the page three, in count 3, 2, 1. Okay, thank you very much. So finally, we come to the end of the session. And on behalf of the committee of Icramet 2020, I thank to all the presenter and participant who has contributed and participate in this session. So thank you very much and good day.
Halo. Halo. 1, 2. Sudah. Suara saya sudah masuk. Apa?
Ladies and gentlemen, now that the last paper presentation session, that was session 17, has been finished, we are nearing the end of Icramet 2020. The final session is a keynote talk from Assistant Professor José Luis Silva from Instituto Universitario de Lisboa, Portugal. To moderate the session, we will introduce Dr. Esa Prakasa from Research Center for Informatics, Indonesian Institute of Sciences, LIPI. First, I would like to read the short biography of Dr. Esa Prakasa. Esa Prakasa received his Bachelor of Engineering in Nuclear Engineering in 1998 and the Master of Engineering in Electrical Engineering at 2001 from Universitas Gadjah Mada, Indonesia. He obtained his PhD in Electrical and Electronic Engineering 2014 from University Teknologi Petronas, Malaysia. He is a researcher at the Research Center for Informatics, Indonesian Institute of Sciences, LIPI, since 2005. His research interests are computer vision, 3D medical imaging, visual inspections, and pattern recognition. He has been involved in some research projects related to digital image processing and pattern recognition for various applications. He has contributed to developing an imaging-based technique for assessing psoriasis skin disease. Since 2014, he has been involved in a collaborative project between LIPI and Terus, Switzerland. He contributed to developing visual inspection methods for assessing sensor chip qualities at production and detector construction stages. The detector will be used in ALICE, a large ion collider experiment project, one of the larger physics experiments in the world hosted by CERN. Please welcome Dr. Esa Prakasa.
Okay, thank you, Miss Ardita, for introducing me as a moderator in this session. Ladies and gentlemen, may I have your attention? The keynote talk is about to begin. Honorable distinguished participants, ladies and gentlemen, very good afternoon. Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to welcome you all of this last keynote lecture of the Icramet 2020. I hope all of you still have a lot of energy to join this session. In this session, we will have a lecture from Professor José Luis Silva entitled Interactive Systems Towards Improved User Interactions. Before the presentation begins, please allow us to introduce Professor José Luis Silva. Professor José Luis Silva received a master's degree in Informatics and System Engineering from University of Minho, Braga, Portugal in 2007, and the PhD degree in Computer Science from the Portuguese MAP-I Consortium in 2012. The consortium consists of 3 universities: University of Minho, University of Aveiro, and University of Porto. Then from 2012 to 2013, he performed a postdoc at the University of Toulouse in France in collaboration with Airbus. Then from 2013 to 2016, he was invited as an assistant professor with the Exact Science and Engineering Department, Madeira University, Portugal. Then since 2016, he became as an assistant professor with the Department of Information Science and Technology, Instituto Universitario de Lisboa, in Lisbon, Portugal. His work has been published at many journals and venues, such as IEEE Access, IJHCS, ENTCS, ACM EICS, and Interact. His main research interests lie upon software engineering, human-computer interaction, human-robot interaction, and ubiquitous computing. Currently, he is a member of both LARSIS Laboratory and ISTAR IUL Research Centers. Professor Jose Luis Silva is also an observer at the IFIP TC13 Working Group 13-2. The IFIP is the International Federation for Information Processing, Technical Committee on Human-Computer Interactions. He also have received some awards and honors, such as FCT doctoral degree grant from Portuguese government, and then ISCTE IUL Scientific Award, Best Iberian PhD thesis in System and Information Technologies from IST, and PhD Award from Fraunhofer, Portugal Challenge. All right. Now I would like to welcome Prof. Jose Luis Silva to deliver the lecture. The duration of the lecture is 50 minutes, including Q&A sessions. Okay, Professor Jose Luis Silva, the floor is yours.
Okay, thank you for the introduction. So I will share my screen. Can you see it?
Yes, Prof.
Okay. Okay, so good afternoon. It's still morning for me, but good afternoon for everyone. So before I start, I just want to be sure about the time I have. You said I have 15 minutes. That's it. Or can you please just confirm for me to be more accurate?
Sorry.
14. Okay. Thank you. Okay, so I'm Jose Luis Silva, and I'm from LARSIS and University Institute of Lisbon in Portugal, as the moderator just said. And I'm going to present some of the work I've been working on in the last years, all of them about interactive systems, in which all of them aim to mainly improve the user interactions of the users. Okay, so I will start just by trying to make some motivations about interactive systems. So as you probably know, interactive systems are I have to move this away. Okay, so interactive systems are systems composed by a significant amount of interaction between humans and computers, and because we have the humans in the loop, it poses several challenges. In particular, if you look at the emerging ubiquitous computing environments, where the interface between the human and the computer is becoming invisible, and changing the way the user interact. This poses an additional challenge because it's more difficult to provide a good interface for the users to interact with, because they tend to be invisible. So the challenge in the development of the systems like this is, first, we have to understand the human, and we have to understand some of those limitations. So for instance, just to give you some background of that and some motivation, if I, for instance, ask you how many cars do you see in this image, well, what will be your answer? Can you see 1, 2, 3? Okay, so you might see two cars, maybe it is one here in behind, and here the van, and the third here the Porsche. But in fact, this one is not. In fact, this one is not. This one is not a car. Okay, it's just printed in the van. Okay, so this is an example where you can. This is an example where you can see that we need to first understand the user. In many cases, this is just an example where the user think that he sees something that in fact is not reality. Okay, so when you develop interactive systems, and because we are dealing with humans, you have to try to understand them well first, and then start to create our systems or solutions. And here is another example of the particular skills of humans. For instance, this text doesn't have the letters in the words in the right position, but despite of that, you can probably can read it quite easily. So the human mind is able to deal with this, okay, and help you to read the text. So this is another example that one important thing is that we need to understand the user, okay. So the second thing is that sometimes when we deliver software for users, we have to take into consideration the time that we have to take into consideration the user wants, okay, but we also need to take into consideration the user needs, okay, because sometimes the users ask for something that it doesn't need but wants, okay. So this is one example of in this sense, where you have here a fridge which is equipped with a small camera, and it enables to detect the facial expression of the user, and it only opens if the user is smiling, okay. So at the first look, you might think that this is not the fridge that you like to buy, okay, because you want just a fridge that opens and keep your things cool inside. But if you think in another direction, for instance, and associate with the fact that we smile when we are happy, but we also becoming happier if we smile. So this fridge helps you to tend to be happier, because it asks you to smile every time you open it, okay. So this is in a way a funny example that shows that sometimes you have to focus on the user needs and not only on the user wants, and sometimes also find a balance between those two aspects, okay. Okay, so moving on to more technical aspects, I will also focus in the first part of this presentation about prototyping of ubiquitous computing environments. So the development of these systems pose several challenges to the developers. So because we want to try to reduce the costs of the development, so we would like to create prototypes, and we want to be able also to identify potential user problems in the early phase of development to avoid high costs associated with a development that then has to change, okay. And for that, we propose prototyping. We propose the prototyping approach for those kind of systems. And as an example to illustrate the concepts, I will use this smart library example, which has with the main goal is so for example, the user go to the website of a library, he requests a book, and then when he arrives at the library, the system detects the user, so the library lets the user enter, and then provides directions to the user in his smartphone or in screens that can be present inside the library. The system sends directions to the user with the path that the user should follow to reach close to the book that he previously requested. So if you think that you want to prototype a system like that or develop a system like that, you will need several requirements. So you will need running software, several devices, sensors to detect the presence of the user, for instance, and all of this means high costs. Okay, so in order to try to reduce those high costs into prototyping of a solution like that and being able to identify potential user problems in the early phase of development, what we proposed is an approach which is based on two parts. In one side, we will have models, okay, which enable us to think about the model that we are to think about the system that we are developing and use those models to specify the behavior that we plan to provide, and use those models to create the prototypes. Okay, so prototypes with more immersive prototypes than the models. Okay, and we want to be able to perform analysis in both sides. So we want to see if we want to perform analysis. I mean, we want to check properties to see if the system works always as expected. And we would like also to perform other kinds of analysis into more immersive prototypes in order to, for example, in the smart library, always that the user get close to the book, the light is on the book will always turn on. Okay, for instance, this is the kind of analysis that we want to perform in both sides. Okay, so with this idea, we came up with this framework, the PEX framework, which is mainly composed by two parts. Okay, in the right-hand side, we have the CPN models, which are colored Petri nets, okay, which is a formal models which is used to develop to model interactive systems, and it's also used to perform formal and exhaustive analysis on them. Okay, so we use this model to create the prototype. So the behavior of the prototype is created using those models, which enable us to perform the analysis, which is important in the development of a critical interactive system, but not only. So this is always important to check properties for the system to work as expected. And in the left-hand side, we have a 3D application server. For that, we use the Open Simulator, which provide a 3D simulation of the prototype that we want to create. Okay, and the Apex framework will come in between the two components, and we enable the CPN models to drive the behavior, the dynamic behavior of the 3D simulation. Okay, so the approach is based on 3 layers. Okay, so the first layer is then the modeling layer. This is the first one. So initially we can model the UbiComp environment only using this layer, and we can create several models and perform some exhaustive and systematic analysis on them. Then when we want to experience a more immersive experience, so if you want to experience the space and see how the user react to the space that we are prototyping, we will add the simulation layer, okay, which will provide a more immersive experience, and where we can connect real users, but we can also have users as avatars, which can be automated. And finally, we will have the physical layer if the resources are available. So if we have the sensors, or if we have smart devices, we can connect them to the prototyping tool, to the Apex, and in this way we can provide an even more rich experience to the users of the prototype, because they will interact with prototype not only by navigating into virtual environment, but they will also receive information from the smart device that are connected to the prototyping tool. And we can also read information from sensors, so physical sensors that can be also connected to the simulation. So this means that we can prototype UbiComp environments at different layers and with different layers, depending of the aspects that we want to evaluate with the users. Okay, initially we can start only with models, and then we can add the simulation of physical layer to provide a more immersive experience and more rich, and also to analyze these different aspects of the prototype. Okay, so to make it a little more clearer, I have here a small video which shows a concrete example using the smart library. So we have here as a part of the Colored PetriNet model, where we have here some users. So in this case, we have one user, one smartphone, some dynamic objects which represent two books of the library, and we have also some sensors, so presence sensors, and so on. And then we have some models that model the behavior of the dynamic object of the library. Okay, so this model, which is the Colored PetriNet, will change its state by moving some tokens from one state to another, and this change of state will update the state of the library. Okay, so in this case, the user arrived at the library, it was recognized by the system, and then depending of the position of the user inside the library, so the position is detected by those red squares which represent presence sensors, the system sends directions for the users with send the direction that the user has to follow to reach the book that you want. Okay, so in this case, the information was to go left, and then the user went left, and when the system recognized that he was close to the book, a light on the book was turned on to help him to identify the location of the book inside the library. So as you can see here in this example, in the CPN models, we can check properties and think about the behavior of our system, but then connecting the model with the simulation layer, we can evaluate different solutions with the users. So we can check, for instance, if the message in the smartphone are adequate, or will it be better to provide directions using smart screen inside the library or using lights on the floor. Okay, so we can experiment different solutions, and all of this with reduced costs, because we can do this in a virtual environment, and we can also connect physical devices to try different designs before moving on to the physical implementation. For instance, when you saw in the movie the window here, the pop-up window with the direction that the user has to follow, this can be substituted by the connection of the physical smartphone, and the user can interact with the virtual environment and receive the directions in his physical smartphone. Okay, so we could also experience this solution using both layers, the physical one and the virtual one. Okay, so we evaluated this prototyping approach with several software engineers, and we got some reasonable acceptance. So they were able to extend the models, and they were able to create prototypes using the Apex framework with a training session of 4 hours. So we found the results that were good. And the more negative point was the time consuming associated with the creation of the virtual environment. Okay, because because of that, what we then developed was some tools that help to create 3D virtual environments from blueprints. So, and this well helped in reducing the time and the costs of developing the 3D environments of the simulation layer. Okay, so to sum up this part of the Apex framework, the Apex framework supports the whole prototyping cycle of UbiComp environments. So we can create prototypes with reduced costs, and we can evaluate different solutions in the early phase of development and identify potential user problems. Apex also supports evaluation of usability and situate impact of a proposed design. And it supports an hybrid prototyping approach, interchanging so physical and virtual devices. We can have in the simulation real user and programmed avatars, and we can also perform systematic and exhaustive analysis into models and analysis into virtual simulation. Okay, we then also applied, well, we used the Apex framework in several scenarios, and one of them was into application into enrichment, into technical enrichment of a senior care home in Braga, Portugal, where the idea was to try to create a prototype of a UbiComp solution and to evaluate several design solutions with inhabitants and with the nurses and the workers of the senior care home before moving on to a real system implementation. So this is the aspect of the senior care home, the blueprints. Then we automatically created this 3D virtual representation from the blueprints, and this is the aspect of one of the physical and corresponding virtual room. And then we performed then a participatory design with the inhabitants of the home care and with the nurses. So we proposed several solutions. We showed them several solutions. For instance, a solution with presence lights in the floor to help the inhabitants to go to the bathroom at night, for instance, some lights into rooms to help the nurses to know if the inhabitants are inside the room or not, and also a system that indicates the position of the inhabitant inside the care home when a fall was detected. Okay, and so this will help the nurses to identify to receive an alert and to receive and to obtain the location of the inhabitant of the elderly inside the home. So we showed those solutions in the participant designs to the participants, and some solutions were well accepted. For instance, the alarm and the presence, but the lighting floor, for instance, was not well received by the inhabitants. They said that this was not necessary. So, but this shows that this participatory design showed that we were able to use the Apex framework also in the early phase of development together with the future users to show different design solutions and to see what can work and what doesn't work so well for the participants. And in this way, we can also, in runtime, update the solutions and show to the participants improved version. Okay, so I will now move into the rest of the presentation to a different topic, which is about human-robot interaction. So this is another topic I have interest in, and I have done some work. And but again, this is about interactive systems and about improving the way the users interact with the system, but in this case, using robots and focusing in particular in the teleoperation. Okay, so those are two robots that we are using. They are from my colleagues from the Institute for System and Robotics from the Technical University of Lisbon. And this is an example of interface that was used in a search rescue scenario using those robots. This is the old version, and this is the new version. And the name of the robots are reposed. Okay, and the works that I've been doing on human-robot interaction focus mainly on the development of multimodal user interfaces and trying to minimize the gap between teleoperation of robots, because as you probably know, so when we teleoperate a robot, there is the operator. The teleoperator is in a physical place that is not the same that where the robot is. Okay, and because of that, because of this gap, because of this fact, there is a gap in distance, in environment perception, in time, for instance, because when you teleoperate, you only see what you obtain by the screen, obtained by the cameras of the robot. And for instance, we can have difficulties to assess with precision the distance, because it's difficult by using a camera to be sure about the distance. It's also more difficult to have adequate awareness of the situation. So there is a gap. And what we aim to explore is to provide some multimodal interfaces, so interfaces that use different channels, not only the visual, but also the haptic channel, for instance, to try to reduce this gap and to improve the efficiency and effectiveness of the teleoperation by their users. Okay. So the architecture. So the architecture is the one that is presented in this figure. Okay, so we have here the users that usually teleoperate the robot using a controller, which can be a joystick or a gamepad, and send some interact with the controller, and then this interaction is forwarded to the robot, and then the robot will update his state, okay, and provide some information back to the user. And this information can come from different elements. It can be from the cameras, from the inertial measurement unit, from the tracks, lasers. All those information are typically provided back to the user via the graphical user interface and using the visual channel. Okay, typically this part here. And what we propose is to develop haptic devices. In this case, we developed two haptic devices, an attitude device and attraction device, which aim to explore the haptic channel to provide additional information to the user without overloading the visual channel. So the idea is to try to provide information about the attitude of the robot and the traction state of the robot by reducing the overload of the visual channel. So instead of having everything in the visual channel, which might be difficult for the user then to assimilate all those information, we divide the information into different channels and try to, in this way, to improve the effectiveness and efficiency of the user in this way. So I will then now move into a bit more detail into about those two devices that we developed. So starting by the haptic traction feedback devices, this device is simply composed by a glove, which has 3 vibration elements, okay, which associate with an algorithm in the robot that detects the traction state of the robot. For instance, the algorithm detects if the robot is stuck or if the robot is sliding. And then based on this detection, we provide, using this glove, information about the state of the robot. So if the robot is in normal state, there is no vibration. If the robot is stuck, only one element of the glove vibrates. And if the robot is sliding, we have a pattern of vibration in the glove that will help the user to notice that the robot is sliding. Okay, and in this way we can use the haptic channel in this way to indicate traction loss of the robot. And this is important because if we, for instance, provide this information in the graphical user interface, it's more easy for the information to be unnoticed than using the haptic channel. Okay, and for instance, you can think that well, just by looking at the image, the user can understand if the robot is sliding or if it's stuck. But in fact, this is not always simple to notice. Okay, because there is a lot of information and a lot of stress in rescue operations. That there is a lot of information that the teleoperator has to process looking at the graphical user interface, and sometimes the teleoperator feel disoriented and have difficulties to obtain adequate situation awareness. So these kind of solutions help in this direction. So the other device that we developed is this one, which is presented here in this figure. It's the haptic attitude feedback device, okay, which helps the user to identify the attitude of the robot, and it allows the operator to perceive the dangerous orientation angles of the robot, and also sudden change in terrain inclination, and also feel the roughness of the ground. So the user, the teleoperator, has to hold the stick in one hand, okay, and this device will change its state. So it will, it has different degrees of pitch and roll, okay, and based on those change, the user will be able to identify the attitude of the robot. Okay, so this is maybe more clear here in this figure when we can see here a user using our devices while teleoperating a robot. So the user here is using our haptic glove together with a space mouse to interact, to send commands to the robot. Okay, and when a traction loss or when the robot is sliding, this information will be provided to the glove. And here, with the other hand, the user will hold the stick and will be able to feel the roughness of the terrain, because this device will change his attitude based on the attitude of the robot. So the pitch and the roll will change based on the attitude of the robot. So this will also enable us to have a better awareness of the attitude and of the situation of the robot that we are still operating. Okay, so then still using those same devices, we are now still in another project trying to apply them into remote operation of planetary ground robots using multimodal interfaces. So we have this project, which is MEROP, which is running on Amadi 2020, which is organized by the Austrian Space Forum together with the Israel Space Agency. And what we aim to do is to provide those devices to the astronauts and to see if they help them to be more effective in the tasks that they will have to perform in the moon, for instance, or in Mars. Okay, so we want to minimize the exposure of the astronauts to the harsh conditions outside the habitat and improve the perception of the situation of the rover during scientific missions. Okay, and for that we will provide them with our 2 optic devices. And so our scientific hypotheses are the use of haptic traction and attitude cues improve situational awareness when compared with only visual information. And the experimental scenario will be the inspection of base condition from the exterior and the exploration of regions of interests. And what we expect as a result is that using haptic cues for traction and attitude awareness will improve the operator performance and situation awareness, and will reduce operational mistakes, and will in generally be able to make the astronaut more effective and more efficient while performing the tasks that they have to perform during the exploration. So this is one image of the place where the experiment will take place. It's the Negev Desert in Israel. So the experiment was planned to be in 2020, in November 2020, but due to the pandemic, it was delayed to 2021. So next year we will have our experiment here in the desert. So trying to simulate the experiment that will happen hopefully in the future in the space. Okay, so finally, I have still some minutes. So the last work that I want to present to you is the most recent one, which has not been published yet, which was not published yet. So this is still ongoing work, and so which deals with the use of physiologically attentive user interface for the robot teleoperation. So, as you have seen, we have two robots. Okay, this is the new version. This is the old one, and the old one was not very. So in the last times, it was not used a lot. Okay, we used mainly the first one, because the interface of this one was not really adequate, okay? And we could not improve the interface of it because we didn't have access to the source code, okay, of the software that was, of the graphical user interface that was associated with this robot. So this is why we mainly use this new robot. So this fact led us to a new idea of investigation, was to try to be able to update the graphical user interface of a solution that we didn't develop. So instead of trying to develop a new system from scratch, we want to explore solutions to improve existing graphical interface without the need to create one from scratch. And also the other idea is try to collect some physiological signals from the teleoperator and use those signals to identify the state of the teleoperator, for instance, stress and workload mainly. Those are the two states that we are dealing with. and try to dynamically change the graphical interface in runtime based on the state of the user, okay? On the emotional state detected from the user data, okay? So this is the original graphical user interface. As you see, this is a lot of information going on. So the attitude of the robot, some information about the power, about the sensors and the different cameras of the robot, okay? So there is a lot of information. And so the approach is that we want to develop a system that will reduce the workload, reduce the stress, and increase the operator's efficiency, effectiveness, focus, and will be also, we aim also to be helpful and satisfy the operator. And so the idea was, so if we were able to detect the emotional state of the user, for instance, if we detect that the user is in a situation where he feels workload, we will update the interface that he will see in runtime, and we will remove some elements that we think are not so important for the task that he is performing in a moment, in a specific moment. Okay. So, for instance, this is the example of the transformation of the interface from this to this. If we detect that the user is feeling workload, okay. So as you can see, we give emphasis here to the image from the camera, and we remove the information of sensors to avoid distracting him. And in this way, we hope that this new interface will help him to reduce the workload and to be more efficient and effective while performing the task. So this is the apparatus that we used. So we use Vitalino to collect the physiological signals, ECG, EEG, and so on. We used the Toby to detect the fixations, and the camera to detect the facial expression of the user. Okay? And then we combine all those information. So this is the architecture of our solution. So we combine all those signals from Vitalin, from Toby, and from the camera, and then we developed an emotional state classifier that analyzes those signals and try to classify the teleoperator into three states: rest, stress, and workload. And then if the user is in rest, we don't perform any change in the graphical interface. If the user if we notice that the user is in stress, we change the graphical user interface, and also if you detect that the user is in workload state. Okay, and as you can see here, the old interface is still running, but we hide it in a virtual machine, and then we use the SQLi to be able to interact with it and extract some information that will be used to populate the information that we present in the new attentive user interface. Okay. So we try to verify 4 hypotheses in a first user study. So we try to identify if the efficiency, effectiveness, and focus, and also the usefulness and satisfaction can be verified. And based on well, before that, this is the setup and apparatus. So we can see here that we have used the camera, the Vitalin, gamepad, Toby, and you have here the user using all those devices and that were used to collect different information. And then, while performing the evaluation with the user studies, we saw that we didn't get significant results results for the first 3 hypotheses, so they were rejected. But we think that this is because the small number of subjects during our first user study, because we had access only to 3 participants. And we also think that this is because also of the poor performance of our classifier. Okay, so for the first 3 hypotheses, the results were not significant yet. But for the last hypothesis, we identify results towards statistical significance. So in relation to the improvements in usefulness and satisfaction of the user. So what we plan is then to perform additional user studies with more participants and try also to improve our classifier to be able to obtain statistical results out for the 4 hypotheses that we want to verify. Okay, and with that I conclude my talk. And thank you all for your attention, and I'm happy to answer any question if you would like to. Okay, thank you.
Okay, thank you very much, Prof. Silva, for the insightful and interesting presentation. I think you already present research and technology related with the how we can interact with the computer system. I think it's very interesting for us. Now I will open the Q&A session. Maybe for the first opportunity, I can give for 2 questions. Yeah. For the participant, you may use raise hand function in the Zoom, and then I will call you, and then you may ask the question directly to Prof. Silva. Let me check. There is one question from Dr. Isnandar.
All right, thank you very much for this time. This is a very interesting for the last session. And regarding to the improved user interface, user interaction, sometimes the improved user interaction use more processing power than the other type of interface. And then sometimes slower for experiencing the user, and then often require you to access multiple menu screen to perform a simple function. How do you think about these 3 problems in improve user interaction? Thank you very much.
So I'm not sure I got the three cases. Can you please indicate? So you said the last one was. Can you? So
right.
it might be better if you can repeat the 3 cases that we were pointing.
All right. Yeah, sometimes the user interaction use more processing power, okay, than the other types of interface, and sometimes slower for experienced users, and require to access multiple menu screen to perform a simple function. How do you think about this this new problem?
Yeah. Okay. So the power relating to the power consumptions, I think that well, in the case of in the scenario we have been using, the power is not a concern for us, but we don't think also that there is much more power consumed in the solution that we are developing. But well, this is something that we can think of. Regarding the additional information to provide access to a simple function, I think that there is a lot of graphical user interface going on which are not which doesn't provide good usability. So in this sense, I didn't present here this work, but I've also worked on some tools that help the developers to reduce the complexity of the graphical user interface. So it aims to, for instance, if you have an already graphical user interface that was developed by someone, we can simplify it without the access to the source code. We can put a layer on it and simplify its aspect. And the third point that you mentioned, the third point was about the experience of the user. Yes. So there is a concept which is universal usability. So which aims to to try to develop systems that are usable by everyone. So, but of course, every user is different, so it's very difficult to achieve a good universal usability. But there are some guidelines that used to be followed to reach those goals.
I see.
Yeah, but it's difficult.
Okay, thank you.
Yeah. Well.
Yeah.
Okay, I
understand.
For the answer, Dr. Iskandar.
Yes, that is enough. My question to answer. Yeah, thank you.
Thank you, Prof. Thank you, Dr. Iskandar. We still have another 2 questions. Maybe for the first participant, they can give the question. I can give to Mr. Hari first.
Thank you. Thank you very much, Mr. Moderator. Good afternoon, Professor Silva. I would like to currently, I mean recently, I've been work on the designing the virtual tour due to this pandemic virtual tour. So the physical, so because we have to make social distancing, so we have to prepare the virtual tour for my office. And I have engaged and discussed with my colleague in the fine art, and we start to talk about the personas. What I want to ask is, would you please please give me a suggestion what the best way to define the personas in designing that virtual tour that would be an interactive. Thank you very much.
Well, maybe a suggestion is, well, you have to identify first the requirements of your users. So identify, if you can classify your users into groups first, identify the main requirements associated with each group. It will then be easier to identify the personas. But I think this is the advice I can give you. So try to identify what is the population of your tour, and try to classify them into different groups and identify the main requirements of each group. Then from this information, we'll try to identify the person. Yeah, but I think that's what I can say.
Thank you very much, Prof.
Yeah. Thank you, Hari and Prof. Jose. We still have one question. Oh, but now it becomes two questions. The next question is from Mr. Ilham. Okay.
Yes.
Please.
Okay.
Continue, please.
Thank you for the amazing presentation, Professor Jose. So I'm interested in the slide about the emotional state classifier. I see that you use Vitalino, and one of the signal is EEG. So for the information, in one of my lab, we also work on the classification on the emotion using EEG signal, but we only focuses on the classifier performance, not the HI, human-computer interaction aspect. So I'm interested in of the HCI testing, such as usability tests, etc. So can you elaborate the methodology of the experiment? Thank you.
But when you say elaborating, not sure if I understand your point. So you want more information in what aspect?
The methodology about the testing in this experiment.
Okay, so maybe I can move to this. So what we did, so I think I didn't went into much detail when I presented, but so this session was divided in two parts. Okay, so we had the first session only for the participant to have a first contact with the teleoperation interface. So we connect the different sensors to the participants, so Vitalino and the Toby and so on, and the user just trained with the teleoperation interface. And this first session was important for us to train our model, okay, or classifier, okay, and we did that for all participants. Okay, we had the first session with all participants. We then trained our classifier with the information that we collected from the different sensors. And then in a second session, we used the trained model for each of the participants. So in this way, we had a model, a specific model trained to each participant, because we thought that it's easier to get better results with a model for each participant. And also we think that it's adequate because in the way that like the user has to train with the robot to learn not to interact and to teleoperate the robot, we will use this training step also to train our model or classifier. And then after this training session, we will be able to use the classifier. Okay, aiming to hoping to have better results. But in this case, the results of the classifier are not really good yet. We have 3 states, and we got only a percentage of accuracy of 50%. So this is a bit better of chance related to chance, because we have 3 states, but this is not yet very good. But because this is also because we only had 3 participants, okay? Because this was during the pandemic, and it was not very easy to get access to participants who accept to have contact with a lot of devices which has the electrodes connect with their skin in their hand, in the head. So they had a lot of Vitalino sensors connected to their skin. So in a pandemic situation, this is a bit more difficult to get more participants. But we think that with more participants, it will increase or improve our results. Okay, so I hope it's more clear now.
Yeah. Okay. Thank you for the answer.
Okay. You're welcome.
Maybe this is the last question, I think. There is another question from Dr. Heru. Okay, please give your questions, Dr. Heru.
Thank you, Dr. Esa. Good morning, Dr. Silva. Nice to meet you. Dr. Silva, this is very interesting, a framework that you introduced called by IPEX framework. Is it will be implemented if we would like to develop something like augmented reality technology, as now we are facing with the pandemic situation, something that some school goes and we need to have online class something. So is it implementing for this such a situation, Prof, to develop the augmented reality technology? And then the second one, I got lost on your explanation on the what kind of the sensor that will implement on your glove robotics controlling. Okay, thank you, Prof.
Okay, thank you for the questions. So, the sound was a bit broken, but I think I got to the point of your question. But in case I'm not, please just tell me. But regarding the first question about developing augmented reality using the Apex framework, it's quite easy. We didn't explore this aspect, but I can go to those slides. So because we have several layers, okay. So in this simulation layer, we can simply connect a 3D head-mounted display, for instance, and we can experience the simulation layer using augmented reality solution. It's quite easy. We didn't explore that. We only explored 3D visualization and multi-display information using the simulation layer, but we can easily connect head-mounted display and experiment 3D experiment augmented reality solutions. Okay, this is something that we can go into the future, but we didn't explore yet. But the framework is open to this aspect. Sorry.
So it is applicable to have the framework.
The second question, in the glove, the sensors are only vibrating motors, okay? There is just vibrations. This is just to help the user to detect patterns. So what we want, the information that we want to provide with the glove is just the traction state. So if the robot is stuck or sliding, so we just have something that will vibrate when the state is detected. So in this case, for instance, we can see that only the first one vibrates when the robot is stuck, and we have a pattern of the three elements vibrating when the robot is sliding, so giving the notion of the sliding. Okay, so this is just vibration. Okay, so this is the aim was to reduce the information, the overload of information in the visual interface, and try to provide information to different channels, in this case to the haptic channel. Yeah. So, but we could add more sensors there. For instance, if we then in the future we can integrate. So in this case, you have two things, right? You have the haptic device, but in the future, if you want to integrate this with the physiologically attentive user interface, we can think that we could have, for instance, some Vitalino parts in the glove. It might be, for instance, easier, or an integrated solutions with additional sensors in the glove might be something that we can think in the future. But right now, the glove is just with vibrating elements.
Okay, thank you, Prof. So meaning this glove only for the vibration, to detect the vibration.
Mm-hmm.
Thank you very much. Thank you, Prof.
You're welcome.
Thank you, Prof, and thank you, Dr. Heru, for the question. I'm sorry, the time is up, and I believe there are still another question from the participants, but unfortunately we don't have enough time for this moment. Maybe in in another time you can contact directly to Prof. Silva, and we hope Prof. Silva is still can answer all of the question. Oh, I'm sorry for the times, for the limited time. I mean, okay. Before I close the session, maybe I just want to make a conclusion, but I think my conclusion is not cannot cover all of the materials. One thing that I understood that during the interaction, the human and computer, normally we only use one sensor or maybe two sensors, but if we can add another sensor, not only, for example, by using visual sensor, we can get more experience, and then we can feel the interaction is more real. I mean, so in the end, we can improve the quality of the controlling of the understanding of the something of the object that we want to know. Maybe that's all that I can understood during the presentation. I think it's very interesting and give a new knowledge for us. Okay. Before we close the session, we want to photo session for all of the participants. So I would like to switch on the camera, so the committee can take the pictures of us. I think it's a good opportunity to take the pictures. So I can count for taking the picture. Please switch on the camera. Okay, my icon for the taking the picture. 3, 2, 1. Smile. Okay, once again. 3, 2, 1. Do we need freestyle? Okay, freestyle. 3, 2, 1. Okay. Okay. Thank you. Thank you for, especially for Prof. Jose Luis Silva for this presentation, and so for all of the participants. Yeah. And also I apologize if there is a mistake during this session, during the last session, right? And then hopefully the keynote can give a lot of benefit for us. Okay, that's all, and thank you, and wassalamualaikum warahmatullahi wabarakatuh.
Thanks once again to Dr. Esa Prakasa to have moderated the final of the keynote talk. As well, thanks to Assistant Professor Jose Luis Silva for having delivered his very interesting speech, and also to all of the participants who has actively engaged in a very stimulating discussion. Now we have come to the final event of the 2020 International Conference of Radar, Antenna, Microwave, Electronics, and Telecommunications. It's a pleasure and honor to welcome all of you again this late afternoon. The Icramet 2020 we have participated in is a jointly organized event by the Research Center for Electronics and Telecommunications, also Research Center for Informatics, Indonesian Institute of Sciences, LIPI. We also have with us Dr. Budi Prawara as the head of Research Center for Electronics and Telecommunications, and also Dr. Purwoko Adi as the head of Research Center for Informatics, Indonesian Institute of Sciences. Also, Assistant Professor Jose Luis Silva, Instituto Universitario de Lisboa. To begin our closing ceremony, I would like to introduce you to Dr. Budi Prawara to announce the best paper and the best presenter awards. Please welcome Dr. Budi Prawara.
Okay, thank you, Ibu Ardita. Can you hear my voice?
Yes, Pak.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon to distinguished speakers, all presenters, and all of participants. I am Dr. Budi Prawara, the Director of Research Center for Electronics and Telecommunications, Indonesian Institute of Sciences, LIPI. Yeah, firstly, I would like to thank you, all of you who have been joining and attending this conference. For the keynote speakers, and just we saw the presentation from Professor Silva. Thank you very much for your interesting presentations, and we appreciate your valuable time to give a lecture in this afternoon. Yeah, I would like to announce the awards given to the best paper and the best presenter in this conference. And yeah, before that, the criteria for the best paper, considering the feedback from the reviewers that cover the novelty or the originality of the paper, its argumentation and discussions, clarity, similarity ratings, and the quality of the overall submissions. And the best paper goes to the title of Broadband High Gain Microstrip Yagi Antenna Array for Millimeter Wave Communication Systems by Gu Bai from Southwest Jiantong University, China, Yuazi Liu from University of Ottawa, Canada, and Cheng Liao from Southwest Jiantong University of China. Please give a round of applause. Mr. Gobai, are you here? So if you still joining us, would you please to turn on your video?
I think he's not with us anymore.
Oh, yeah. Okay. Yeah, congratulations for the best paper. Yeah. And for the best presenter awards, we consider the promptness of submissions, presentations timings, clarity and logical flow of the presentations, also the quality of answering questions. And the best presenter goes to Aminul Solihin from Institut Teknologi Bandung, Indonesia, that has given the presentation title Signal Processing Algorithm for pre-processing the surface plasmon resonance signal response. Is it here? Mr. Aminul Solihin, would you please turn on your camera? Okay. Yeah. Yeah. Yeah.
I think we've been trying to reach him, but we received no response. So I think Pak Budi, we
Okay.
can continue to next. Thank you, Pak Budi.
Yeah. We continue. So congratulations to all of the awardees. I hope this token of appreciation will further motivate you to contribute in your research disciplines. Having said that, I would like to express my utmost gratitude for all presenters who has presented their research finding in Icramet 2020. I hope through this conference you have gained some insight and inspirations that can benefit your next research activities. I hope you will continue to share your research findings in the next Icramet conference. Thank you.
Thank you for Dr. Budi Prawara for announcing the awards. Next, we will have Dr. Eri Dwi Kurniawan as the chairman of Icramet 2020 to present us with the closing speech and ceremony. For your information, the certificates will be circulated after the conference ends, so please check your email regularly. With this, I would like to bid farewell to all of you. Thanks for having me as your MC for these 3 days of Icramet 2020. Till we meet again, perhaps in the next conference. Hope you stay safe and healthy. Now, to close this conference, please welcome Eri Dwi Kurniawan.
Okay, thank you. Very good afternoon, all distinguished keynote speaker, invited guests, presenter, and all participants. Finally, we have reached the end of the 2020 International Conference on Radar, Antenna, Microwave, Electronic, and Telecommunication, Icramet 2020. It has been intensive 3 days conference, very productive, fruitful, and wonderful presentation from all keynote speaker and presenter. We have achieved a lot, and I am very glad that I still see so many people join to attend this closing ceremony. From 77 accepted paper in Icramet 2010, there are 74 papers already presented and discussed in this conference. I hope that this conference can create the collaboration between us, researcher, scientists, engineer, scholar, student, and practitioner that interest in the advanced technology of electronic, telecommunication, and information technology. New ideas, knowledge, and amazing technology that discussed in this conference, I hope can foster a new innovation to realize a smart society. I also want to say congratulations to all awardees of the best paper and the best presenter. So finally, in this moment, I am as the chairman of Icramet 2020 officially conclude this conference. On behalf of organizing committee of Icramet 2020, I would like to thanks to all keynote speaker, invited guests, presenter, participant, and all committee member of Icramet 2020 for supporting this conference. I also apologize if there are some mistake or technical error during this conference. So stay safe and keep healthy during this pandemic. See you in the next year conference. Thank you and goodbye.